Hello. We're back at it again. Alright. Now, before I start, I should say what I want to get done here. So, we'll see how reasonable we can get things done. We will say this morning routine is done, but we go with Leetcode. We finished the lecture that we were watching last night. We have to finish, I'm going to say the rest of exam paper questions for this subject CS. Then do the math extensions, and hopefully by then it'll be around lunch. I might go for a walk after lunch and obviously have a shower. So those three things, and then I will say that I'll be able to do the math extension, then maybe watch a lecture, then maybe schedule a development. Tutorial week 10, this is unlikely. I don't think I will be doing this today. Understand MST solution is one other thing. This top job though, this TOP, is going to be marked as cancelled, so I'm not doing that. Understand MST solutions. This is for CS. But yeah, we're gonna move these two tomorrow. Alright. We're gonna move these two tomorrow. And just do that. Okay. Cool. And the upcoming is gonna be we gotta look at the upcoming a little bit as well at some point. But this is the plan. This is the plan right here. So we'll start off with the Leetcode. I'm gonna try do the Leetcode slightly more differently just today, in the sense that I'm going to. Oh. I think my dad's home from walking. I'm gonna read the problem. If I can't think of an answer straight away, I'm gonna look straight to the solutions and then look up until he starts coding, and then I'll just code it from there. That'll be the plan. All right. Okay, using enter using standard int main vector int vect 10 20 30 40. Vect x int x vect Advanced graphs. Alien dictionary. There is a foreign language which uses the Latin alphabet, but the order among letters is not A, B, C, Z, as in English. You receive a list of non-empty string words from the dictionary, where the words are sorted lexicographically based on the rules of this new language. Derive the order of letters in this language. If the order is invalid, return an empty string. If there are multiple valid orders of letters, return any of them. String A is lexicographically smaller than string B if either of the following is true. The first letter where they differ is smaller in A than in B. There is no index I such that AI does not equal to BI and A length is less than B length. So the input is Z and 0, so the words Z and O, output 0. Explanation from Z and O, we know Z is less than O, so ZO. So HRN, HRF, ER, EN, HER, and F. So HRN, HRF, we know N is less than F. From HRF and ER, we know that H is less than E. From ER and E and N, we know R is less than N. From ENN, RF, and N, we know that E and R. So E is less than R. So one possible solution is HERNF, where N is less than F, H is less than E, R is less than N, and E is less than R. The input words contain characters from the lowercase a to z. So let's read this one more time. So foreign dictionary, there's a foreign language which uses the Latin alphabet, but the order among letters is not A, B to Z. You receive a list of non-empty strings from the dictionary where the words are sorted lexicographically based on the rules of the new language. Derive the order of letters in this language. If the order is invalid, return an empty string. If the order is invalid, return an empty string. There are multiple valid orders of letters. Return any of them. String A is lexicographically smaller than a string B if either of the following is true. The first letter where they differ is smaller in A than in B. There is no index I such that and A to length is less than B to length, which to me means that there has to be at least a bit of distinction, or it can't be like a subword. So in this example, the input of Z and 0, Z and O is ZO, because from Z and O we know Z is less than O, so you return ZO. A string A is lexicographically smaller than a string B if either of the following is true. The first letter where they differ is smaller in A than in B. Okay. Let me sit down. Okay. Now this is kind of hard, and I don't even see how this could be done in an advanced graph. So this is definitely going to be something I just will look at the solutions for. But look, my understanding is HRN, HRF, you look at these two and you realize the first time that it doesn't match is on the second index, where n is not equal to f, and so you're saying n is less than f. HRF, ER, so you said the first time it doesn't match is HRF and ER, and ER and EN and this. Okay, now another thing is we'll open it up in a separate. You want me to subscribe to unlock? Leetcode doesn't even share this problem. Alright, well that's alright. Alien dictionary. Well, that's a problem. Alien dictionary from Geeks for Geeks. Alright. This is gonna be topological sort. What? Okay. Let's say obsidian. Create this new file called Alien Dictionary. I don't even know what number this is. Alien Dictionary, Leetcode 269, I guess. Alien Dictionary. Adjacency lists. Look, I'll put it on the advanced graph. Advanced graphs. Adjacency, I guess we'll just put adjacency list as well. An adjacency list. Topological sort. How long does this video take? 22 minutes? Alright, that's fine.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem Alien Dictionary. And yes, this is another problem from the blind 75 list. This is the problem 32, a graph problem, Alien Dictionary. I've been wanting to do this problem for so long now, and we're finally doing it because now we actually have Leetcode Premium. And again, thank you for all my Patreon supporters for making that possible. So let's get into the problem now. And by the way, the link to this spreadsheet will be in the description if you want to take a look. So this is a pretty hard problem, I will admit. It's a hard graph problem. So this problem is going to involve the algorithm topological sort that you may or may not have used before. You may not have even heard of this before. Topological sort involves a DAG, a directed acyclical graph, a graph that has directed edges but no cycles. So the premise is we're given a new alien language that uses English alphabet letters. So it's going to be basically lowercase a to lowercase z, but the ordering of these characters is unknown to us. Now we know in regular English, the ordering is basically A, B, C, all the way to Z, right? This is the order. There's 26 characters, but basically they're saying that now we have a different ordering of these characters, and the goal for us is to try to figure it out. And what we're given to figure it out is basically a list of words which happen to be given to us in sorted order. They say lexicographically sorted. That's basically just sorted based on how regular sorting of words works. So our goal is to return a string of the unique characters that were given in this new alien language based on the words that were given. And we're going to return this in sorted order, in increasing order, based on the new language's rules. Now, if there is no solution, we're returning an empty string. So we have to figure out what that even means. What does it mean for there to be no solution? And also, there could possibly be multiple solutions, and if there are, luckily for us, we're allowed to return any of the valid solutions. Now, they tell us that two strings, S and T, S is going to be smaller than T if at the first letter where they differ, the letter in S comes before the letter in T in the alien language. And this is pretty intuitive. Like, if we know, if we were given two words such as apple and banana, how are we going to sort these two words? Well, we're going to look at the first character, right? And we see, okay, the first characters are different. And A, we know A is less than B, right? That's how the ordering works in English. So we're going to check just the first differing character. Since A is less than B, that means A comes first in the ordering. So how would we order these words? Basically how they're listed right now. Apple comes before banana. What if we were given a different word, such as apple and ape? Well, in that case, we look at the first characters. Okay, they're the exact same. So we still don't know how to sort them yet, right? We look at the second characters, P, P. They're the exact same. We look at the third characters, P and E, and we know in English the letter E comes before P, right? So the correct ordering of these words is going to be the opposite. It's going to be ape and then apple. Right, so that's how we would sort these words. Now, the difference in this problem is that the input that we're given is already sorted, right? So these words are already sorted. So we're going to use that to our advantage to basically figure out the ordering of the characters, character by character. And there's just one edge case we have to worry about. So if we're given two words where they have the exact same prefix, right? Where basically the shorter word is a prefix of the longer word. If that's the case, that means the smaller word is always going to become first in the ordering. So for example, if we had one word ape and another word apes, no matter what, since this word is basically a prefix of the second word, they match, right? So whatever the longer word is going to be is always going to come after the shorter word. And if that was not the case, what if we were given a list of words where that was not the case? What if we were given apes and then we were given ape? Well, based on what they just told us, that's invalid, right? They say the opposite must be true. So what we can say is if we ever see something like this in our list of words, then we know there's no solution, and that's going to be one case where we return an empty string. So they tell us that this input list of words is supposed to be in sorted order, so we're going to use that to our advantage. And so remember, if these two words are in sorted order, how was it determined that they're in sorted order? How was it determined that this word must come after this word? Well, it must be based on the first differing character, right? That's what lexicographically ordered means. So let's just go for every pair of words. Let's go. go character by character and find the first differing character and see what kind of information that gives us. So let's look at the first characters. Well, they're the exact same. Let's look at the second characters. They're the exact same. Let's look at the third characters. They're different. We have a T that comes before an F. So that must mean in the alien alphabet, T comes before F. So this is not, in regular English, this isn't true, but in our alien language, this seems to be the case. So let's just keep track of that. Let's just remember, okay, T comes before F. Next, let's look at the next two words. So we're going to look at the first two characters, and immediately they're different. So we know that these two words were sorted based on this first character, and we know that E comes after W because they're in that order. We have a character W, and we know for sure E is going to come after that W. Now, who knows? Maybe there are some characters in between here, right? Maybe it's actually going to be W, F, E, something like that, right? But we don't really know that for sure. All we know so far is this is true and this is true. That's all we can assume from this ordering, right? We know that these first two characters are in that order, but the remainder of the characters might be in any order, right? Because when words are sorted, they're only sorted on the most significant differing character. So now let's look at the next two words. Look at comparing each first character. They're the exact same. Let's go to the next character, R and T. Now they're different. So now we know for sure R comes before T. So let's go ahead and do that in our drawing, right? R comes before T. Now, we see that we already have a T in our graph, right? And actually, I haven't actually mentioned that this is a graph, but it's starting to get intuitive why we would want to represent these relationships as a graph now, right? We could separately say R, T, but why not include this node that we already have? So we know R comes before T. We know this for sure. Now time to finally look at the last two pair of words. Look at the first two characters, E and R. So that's the first differing pair. So we know that E comes before R, and we know that R is actually already in our graph. So then we can say, okay, let's take this edge and then hook it up over here. So once you recognize that you can use those relationships of characters and the relative order of those characters to build a graph, this problem becomes doable, right? Then all we need to do is now traverse this graph. Now in this example, it's pretty straightforward, right? Clearly we see that the order is non-ambiguous, right? We're going to start with a W, then E, then R, then T, then F, and that's, going to be the entire order. And you can see that this order is also in the output that they gave us in this example. So this matches up pretty easily. So you'd think, okay, at this point the problem is easy, but actually there's a lot of different ways this graph can be represented, and traversing the graph itself is not super intuitive, and there are multiple ways to do it. You can do a BFS solution, a breadth first search solution, or you can do a depth first search solution, and I much prefer the DFS solution. There's so many more like bookkeeping things you need to do with the BFS solution that I don't really think it's worth doing. I think the DFS solution, even though it's recursive, is just so much better, so that's what I'm going to be focusing on. So let's change this problem slightly. Let's say that this F actually pointed at the W. So now, if we were traversing this graph, what the heck would the relative order be? We could start at any node. We could start at R and then say, okay, T, F, W, E, and then we say, okay, we got back to R, so we already visited that. But is that a valid order? Like, this is very ambiguous. It's not that this has multiple solutions, it's that this is invalid. There's a contradiction, right? What if we had a shorter cycle? What if we had, okay, W, and then E comes after W, and then W comes after E? Do you see how that's a contradiction? We can't have opposite rules, right? It's basically like if we had an input list of words that was something like this. We had WE, and then EE. So clearly we have a differing character here, meaning E comes after W like this. But then maybe we got that same word WE. So how can we say that this list of words is sorted when, the same word is in both positions and then there's another word in between that? That doesn't make sense. Basically, that's how you know that there's a contradiction, and in that case, we return the empty string. There's no real solution, and we know that because there exists a cycle in our graph. Now, what if this last word in our input actually didn't exist? What if we cross it out? In that case, we would never get this connection where E hooks up to R. We have two separate graphs, right? But there's no contradiction here. It's just that now we have multiple solutions. So we could say, okay, the relative order is either we RTF, right? Basically going through this and then doing this one, right? Or we could even do it in the opposite order, RTF, we, right? That's one way. Or we could even do a breadth first search approach, right? Put these two first, WR, then put these two, ET, and then put F, right? All that really matters is that this, like if there's a connection, if there's a directed edge from this node to this node, all that matters is when we return the output string, this character shows up before this one. And similarly, this character shows up before this one, and this character shows up before this one, etc., etc. We really need to guarantee that that's the case. So at this point, you might think, okay, let's just start at the beginning of each of these components and then just go through it, right? Like say, okay, W, E, R, T, F, and then just build the output string like that. And I'll show you one reason why that's actually not gonna work. If we were given an input list of words like this, what we would end up getting is basically a graph that looks like this. And this is a perfectly valid graph, right? What's one valid ordering of this? Well, basically A, B, C, right? That's one valid ordering. But let's say we did a DFS search on this. Let's say we started our DFS here, so we got an A in our output. Then let's say we went to this node first, then we got a C in our output. Then from our DFS, then from A, we see this is the base case. Then we go back up to A. We say, okay, now let's go to B in our DFS. So then we got a solution of A, C, B. Now from our B, what we're going to end up doing is going to C. So in reality, C should come after B, but we see in our input, it came before B. So basically from our DFS, we got an invalid ordering of this graph. So, if we're doing a DFS from the beginning, how do we know that we should be going down this path down to the B before we go down the C path? Well, the answer is we don't really have a good way of knowing if we're doing this with DFS. But there is a workaround solution to that. And the solution to that is going to be doing a post-order DFS. So in reality, yes, we're going to be starting at this node, but we're not going to be adding it to our output yet. We're going to be adding this to our output last. So, okay, we're here. So now we're going to get to C, right? Now we're at C. Now we're going to go farther down C. We see C does not have any children, right? So that's our base case. So now, since this is post order, now we're going to actually add C to the output. So now we're going to end up popping back to A, right? So we're now back at A. So we're going to continue the DFS. This is post order. Let's do all of our descendants before we process A. So let's go to B. Okay, B. And B has some neighbors down to C. Okay, we see C has already been processed. No need to do that again. So B does not have any more descendants. So now we can process B. Let's add B to the output. And now finally we can process A, right? So what you see is that the way we did it now was not ambiguous, right? We didn't end up, or we made sure we ended up doing all the leaf nodes, right? The last nodes first, and then these nodes, and then we finally did A last. So what you can see is that we actually built our result in reverse order, which isn't bad because easily we can take this and reverse it, right? So when we get the output of this, we're going to make sure to reverse it before we return it. So we're going to return A, B, C. So that's the main idea of what I'm going to be doing when we're actually writing the code. That's kind of how topological sort is done. That's how I was taught to do it in school. So it's just a DFS, except we're building the result in reverse order. And there's one last thing we're going to have to keep track of, what we're going to be doing for loop detection. And really what we're going to be keeping track of is two things. Similar to how I did it in the picture, we're going to be marking if a node has already been visited, meaning it's already been, let's say, processed or whatever. And in this case, we know that there weren't any loops. Well, actually, one thing I want to say is first we saw that C was processed, right? Then we went back to A and then we went to B, right? When we went from B to C, we saw that C was already processed, but that doesn't necessarily mean that we have a cycle in our graph. Because yes, this was processed, but it wasn't currently being visited. If we went to C and then C went back to B, right? And then we got to B and then we tried to go to C again, that would indicate a cycle. Basically, if this was currently being visited, but once we go from here, see it's a base case and then pop back to A, then we're saying this is no longer being visited. So what we're going to be keeping track of is two things. we want to know if a node has already been visited, meaning it's already been processed pretty much. And we also want to know if a node is in our current path. So we're going to be doing that with a dictionary. And so every time we visit a node, we're going to say it's added to the dictionary, but we're going to give it a false value in the dictionary. And once it's actually in the current path that we're traversing, then we're going to give it a value of true in the dictionary. With that being said, we can now jump into the code. The overall time complexity is just going to be the number of characters that were given in the input, because that's basically going to determine how big our graph can be. And of course, we're going to have to traverse the entire graph. So it's the time complexity is just going to depend on the number of characters. So this is going to be a long one, about 30 lines of code. So the first thing we're going to...
It's going to be a long one, eh? Well, that's not even that big. Visited character to Boolean value. True current path. Interesting. So I think that's enough for me to build the concepts. The thing is, topological sort adjacency lists. So topological sorting and adjacency list. Okay. If you have a directed graph like this, you can create a linked list. 0 to, and then 2. Why is it 2? So 1 or 2. And then 2 goes to 0. 0 goes to nothing. So each one of these nodes here represent each one of these arrows, edges. Characteristics of the adjacency list. An adjacent list uses a list to list. We store all adjacent of every node together. The size of the list is determined by the number of vertices in the graph. The size of the list by the number of vertices, and all adjacent of a vertex are easily available. To find all adjacent, we need only O of n time where is the number of adjacent vertices. And you can build an adjacency list pretty easily. So it's just interesting, okay. Topological sort. So topological sort for directed acyclic graph. So adjacency representation though, this is a good image. Hmm. 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 Topological sort. So topological sorting for directed acyclic graphs is a linear ordering of vertices. Such that for each directed edge, u to v, vertex u comes before v in the ordering. Vertex u comes before v in the ordering. Note, topological sorting for a graph is not possible if the graph is not a directed acyclic graph. So in the graph where you have 5, 4, 0, 2, 1, 3, 2, 3, 1, 0, the vertex is topological. The first vertex in topological sorting is always a vertex with a degree of 0, with an in degree of 0, a vertex with no incoming edges. So it's either 5 or 4. There can be more than one topological sorting for a graph. Another topological sorting of the following graph is from 4 to 0 or 4 to 1. Wait, 4, 5. Okay, 4, 5, 2, 3, 1, 0. Or it could be 5, 4, 2, 3, 1, 0. Topological sorting versus depth first search. We print a vertex and then recursively call DFS for its adjacent vertices. In topological sorting, we need to print a vertex before its adjacent vertices. For example, in the above, the vertex 5 should be printed before vertex 0. But unlike DFS, the vertex 4 should also be printed before vertex 0. So topological sorting is different from DFS. For example, a DFS of the shown graph 5, 2, 3, 1, 0, 4, but is not a topological sorting. So topological sorting in directed acyclic graphs are a special type of graph in which each edge is directed such that no cycle exists in the graph. But for understanding why topological sort only exists for DAGs, let's first understand the two questions. Why topological sort is not possible for graphs with undirected edges. This is due to the fact that undirected edges between two vertices u and v means there is an edge from u to v as well as one from v to u. Yep, and because of this, the nodes u and v depend upon each other and none of them can appear before the other in the topological ordering without creating a contradiction. So why topological sort is not possible for graphs having cycles? Well, one thing is you can think of, I guess, that if you don't have cycles, if you don't have an undirected graph, you don't have cycles. So, well, actually, it's not always the case, but if you have two nodes and it's undirected, then you don't have cycles. So why topological sort is not possible for graphs having cycles? Imagine a graph with 3 vertices and an edge, 1 to 2, 2 to 3, 3 to 1. Yeah, forming a cycle. Now we try to topologically sort this graph. Starting from any vertex, it will always create a contradiction in our definition. All the vertices in a cycle are indirectly dependent on each other, hence topological or sorting fails. Yeah, so because you can't find a in degree of 0 for any of these nodes, you don't have topological sorting. Hence, a directed acyclic graph removes the contradiction created by the above two questions, hence it is suitable for topological ordering. A DFS-based solution to find a topological sort has already been discussed. Topological order may not be unique. Algorithm for topological sorting using DFS. Nothing about this says post-order of anything. I would expect some mentioning of post-order traversals. Can't say. But look, I kind of have an idea. Could go back actually. Adjacency list representation, put that in a new tab, go back to topological sorting. Okay. Oh, Yorichi, hello. You're implementing MD5 today. Double checking that. All right, nice. What makes you want to do that today? Part of a project or pretty good? I need to look into that, I think, because that's also part of cryptography and security that I'm learning. Okay. I'll look at the solution here, but then I'll write my own solution
What I want to do is going to create that adjacency list, right? Basically based on the ordering of the characters. So for every single character in our entire list of words, what we want to do is map it to, let's say, a set. We could do a list, but a set is going to make sure that we don't have duplicates. So we're going to go through for every word in our list of words, and then for every character in each word, we want every...
Yo, what's the difference between adjacency list and an adjacency matrix? You have a good quest. That's a good question. It's a 2D array of size v times v, where v is the number of vertices. Let 2D array be indicate that there is an edge from vertex to vertex. Yeah. An adjacency list is an array consisting of the addresses of all the linked lists. The first node of the linked list represents the vertex, and the remaining lists connected to this node represent the vertex to which this node is connected. The representation can also be used to represent a weighted graph. This linked list can slightly be changed to even store the weight of the edges. I guess you can also, yeah, these comparisons are good. Storage space. Adding a vertex. The thing I would say, look, from my I guess, quick reviser on adjacency matrix and adjacency list. Adjacency lists, like, let me just describe what an adjacency list is. From any given node, you return the list of nodes that connect to that node. So in this case, 1, you return 0 and 2 because that's where 1 goes to. You can go to 0 or 2. From 2 it can go to 0. And you know, you can encode this in an adjacency matrix in your head. You can kind of think about it where you have a 3x3 matrix and you have 0, 1, and 2. Like, I could encode this if I draw it out. Adjacency matrix. Of 0, 1, 2, 0, 1, 2. For this, it would be 1 to 0. So you might say from on the rows and 2 on the columns. So from is 1, 2 to 0. So this is going to be 1. So 0 itself is not going to go anywhere to anything. So you can say for all of these, it's going to be 0. For 1 and 1 is, it's never going to be actually for itself. So for 2 and 1 and 0, it's always just going to be 0. And then you say from 2 to 0, it's 1. From 2 to 1, it's none. For 1 to 2, it's 1. And that would be the exact same graph represented in adjacency matrix. And you have an adjacency list like this. So, you know, from this, you can see that you're going to have a time complexity. I just wrote O of n by default. You would have a space complexity of v squared. But in the adjacency list, would that be the case? It could be at most v, I think. In the adjacency list, it could be at most v. A L adjacency list. Is that right? So then if I check this comparison, the space complexity, space storage for the adjacency list, or adjacency matrix is O of v squared. Adjacency list is, okay, right, not v, but v, yeah, v plus e, or yeah, plus e. Definitely a good thing to know about, to be honest. So let's delete this now. Alright, but it's good to know about. Ooh. You might also want to know what is an adjacency matrix in comparison to an adjacency list, which is good if you just take a look at this link. All right, good. There's a lot of notes for this specific Leetcode problem. using, I think, Leetcode question, give adjacency matrix, right? Yeah, so, I mean, I don't know. But yeah, this problem specifically that I'm trying to solve uses adjacency lists, apparently, according to Leetcode. So we'll see how he does it.
Want every character to be mapped to a set. And then we want...
What? Anyway, how do you determine the price for someone who asks for a simple ordering website? I mean, that's very random, but yeah. I would say, like, just take into account, like, how much time you would take in total to create an ordering website. You kind of got to gauge at how difficult that is. And just ask for, like, think about you getting paid, like, 50 an hour. If you're getting paid 50 an hour and it takes 20 hours, make that the price.
Want to go through every pair of words. So for I in range, the number of words that were given.
Okay. Now the problem is,
entire list of words, what we want to do is map it to, let's say, a set. We could do a list, but a set is going to make sure that we don't have duplicates. So we're going to go through for every word in our list of words, and then for every character in each word, we want every character to be mapped to a set. And then we want to go through every pair of words. So for I in range, the number of words that were given minus 1, so that we go through every single pair. Let's get each pair. So word 1 and word 2. Word 1 is going to be the word at index I. Word 2 is going to be the word at index I plus 1. So let's get the minimum length of both of these two words. So let's get the minimum of the length of each of them. And the first thing I'm going to check is basically that base case, that edge case that we first mentioned. So mainly if the minimum length of each word is the exact same, right? Meaning the prefix of the words is the exact same, but the first word is longer than the second word, in which case we know that we have an invalid ordering, right? That's kind of the edge case that they explicitly mentioned. So the length of word 1 is greater than the length of word 2. They have the exact same prefix, meaning that it's an invalid ordering, basically. So in that case, we would have to just return an empty string. If that's not the case, we want to go through every single character between these words. So basically in range, min, length. And our goal is to find the first differing character, right? So if the characters are the same, we're not going to do anything. But if the characters are different, so the character at position J in word 1 is different from the character at position J in word 2, they're different, not equal, then we're going to break. But before we break, we're breaking because we only want the first differing character, so we don't want to look at any subsequent characters. But before we break, we want to add this to our adjacency list. So we want to say that the character in word 2 comes after the character in word 1. So we're going to indicate that by saying, okay, word 1 is the key at index J, and to that we're going to be adding word 2. So that's how our adjacency list is going to work out. So once we do this, we can actually start.
Okay, now, like, he does an adjacency list which consists of a set in the dictionary as opposed to an actual linked list. Does that matter? You know, I guess, you know, reading wise, checking if a value is in the list is an operation that is faster when using a set than using a linked list. Linked list worst case is O of n, and maybe that's why he uses a set instead. That's something to consider. Okay.
Doing our DFS, and remember, for our DFS we're going to be making sure to keep track of visited nodes. So we're going to use a hash map or dictionary, and for each node or each character we're going to be mapping it to 2 values. False basically means that the character has been visited, True means visited and it's in the current path, right? So clearly if it's in the current path, that means it's been visited, right?
Hold on, so visited and current path. Okay, if it's false, false equals visited. True equals visited and current path. Okay, that's where it confuses me now.
The key at index j, and to that we're going to be adding word 2. So that's how our adjacency list is going to work out. So once we do this, we can actually start doing our DFS. And remember, for our DFS, we're going to be making sure to keep track of visited nodes. So we're going to use a hash map or dictionary. And for each node or each character, we're going to be mapping it to 2 values. False basically means that the character has been visited. True means visited and it's in the current path, right? So clearly if it's in the current path, that means it's been visited, right? So saying it's visited is basically redundant, but true indicates that it's in the current path. If it's not added to the visit dictionary at all, that means it hasn't been visited at all. We also want to maintain our result, and remember, we're going to be building this in reverse order, so I'm actually going to...
So, usually this is a visited set. Now, to make it a dictionary means that the value of the key, there is a value of the key, or there is an attribute of this visited node or whatever, which in this case is whether or not it is in the current path.
Make it a list initially, and then we're going to join the characters in that list at the end in reverse order. So we can define our DFS function. All we need to do is pass in the current character or node that we're visiting. Now, if character is already in visit, then we're just going to return. And now what are we going to return? We're going to return the value that's stored in visit. So if it's already been visited, then we're just going to return false. If it's in the current path, then we're going to return true. Now, if this DFS ever returns true, that means we saw a character or node that was already in the current path, and we saw it twice. That means we detected a loop. So if this
we detected a loop.
Returns true, that's how you know we detected a loop. If this is not the case, then what we're going to say is, okay, visit to visit at this character, we're going to be adding true, because not only has it been visited, it's also in the current path. And then at the end, before we return, we're going to say, okay, visit of C is now false, meaning it's still been visited, but now it's false because it's no longer in the current path. That's what we're going to do right before we return. But before we do that, we're going to go through a loop. We're going to go through every neighbor or descendant or character that comes after this character. So basically from our adjacency list that we built earlier, we're going to go through every character that's a neighbor of C, and we're going to run DFS on that neighbor. Now, if this returns false, if this returns true, that's how you know that we have a loop.
So for a neighbor in the character's adjacency list, all of the adjacent nodes. Yeah, okay, so that's what the adjacency list is, right? That's how you apply the adjacency list. It's a good way to know what the next nodes are that you're going to. Okay.
So if this returns...
So by this, it's like you're building out this tree. And then the next part is doing the DFS. So building this graph out like this. Yeah. So this is one way to build a graph. Definitely.
Returns true, then we are going to return true immediately, telling the recursive call that we basically detected a loop, and we can return immediately. Okay, so that's pretty much all for our DFS, but don't forget, this was a post-order DFS. So mainly, after we've done the recursive call, that's when we're finally going to say, okay, to our result, we can finally append this character. Remember, we're actually building this in reverse order. So once we've done the entire DFS, we're going to have to return the result in reverse order. So now we defined our DFS. So now let's actually call the DFS. So for every single character, and we don't really need to actually start at the beginning character of the graphs. We can actually start at any single character and it'll still work out the same. The reason being is because we're doing it in reverse order. And if you don't believe me, you can try drawing out the picture and seeing what would happen if we started it in the middle of the graph somewhere. And it actually does surprisingly work out, as long as you do mark the characters as visited once you actually visit them. So we go through every single character in our adjacency list, and then we call DFS on that character. And if this returns true, then we are also going to return then immediately. We're going to return the empty string, meaning we detected a loop. Now, if that's not the case, that's when we're actually going to return the result. But remember, the result is a list. So what we're going to do is actually join every single character in that list in result. But before we do that, we want to make sure we reverse the result and then we perform that join and return. So I hope this was helpful. If it was, please like and subscribe.
I'm not gonna remember that when I re-implement this. So I'm gonna implement it later because it's already 1 hour. Alright. So mark that off. Lecture 2, week 12. Let's go to that. Why is it, okay, right. Remove all this to this tab. Okay. Do something like that. Hello. Do I need to close anything? I'll keep these open. Maybe I'll close this. And continue watching from here. I'll finish watching this and then eat lunch.
Part of the key to for enforcing substitution, some part for imposing transposition. So, and transposition and substitution and transpositions are the basic ideas through which you can come up with an encryption. Like if one actually gives some confusion, the other one actually gives diffusion. Right? So, and confusion and diffusion principles we discussed, these are the important design ideas for creating an encryption algorithm. So, even in the, so by working with this classical ciphers, which are, straightforward, in some sense, some of these classical ciphers are already broken and you will have automatic tools available online. But you also work through, actually, in your assignment, how you can actually break a general substitution cipher, which is so substitution ciphers come with how many different flavors? 2 flavors. One is mono alphabetic substitution. That means if a particular alphabet goes to another specific alphabet, and all occurrence of the specific alphabet goes to the its substituted version. So monoalphabetic is that A go to some Z, that A go to Z all that in all the text. But as opposed to that, which is the other one, which is much more complex. Monoalphabetic cipher, second one. Tell me. Polyalphabetic, very good. At least okay, one person saved me now. So what I'm saying is that now what you have to do. So if you actually put together, there'll be a lot of information. And if you say, oh, you would have actually exercised all of this on either in the workshop in the next week after this, or on assignment, or on mid-semester test or somewhere. So all these, whatever the concepts come, you go and look at it. First, become familiarized with different concepts that is there. What is symmetric key? What is public key? What is block cipher, stream cipher, hash algorithm, MAC algorithm? What are the properties? You may be able. You can probably write a cheat sheet for yourself in one page. All the new things that are encountered. Will you be able to do that? That is the best way to kind of learn, rather than going through all aspects. Okay? Yes or no? Can you do that? Yeah. I think that's the best way to. Okay? Will you be able to do that? You may be able. You can probably write a cheat sheet for yourself in one page. All the new things that are encountered. Will you be able to do that? That is the best way to kind of learn, rather than going through all aspects. Okay? Yes or no? Can you do that? Yeah. I think that's the best way to. Because remember, this is the only time you have option to do it before you after that, after you graduate, you probably don't have to study them again, and so this is a great opportunity for you to kind of go study this. Studying a subject is also, this opportunity comes only once for you. Like after you passed from masters and then you become a regular employee, you never get that opportunity. Okay, and then of course there are so many other things to learn in life. So here itself is there in polyalphabetic ciphers, monoalphabetic ciphers. So in fact, I actually gave an idea using the we had this Caesar ciphers. Then you can have more than one Caesar cipher and different keys. So then you can actually do a block encryption like a Caesar, and that was one of the schemes which we had. What is that? Like a Varnam cipher. Varnam cipher. So you got a fixed word, and you can actually XOR this word with with a block B. Yeah. So then that will introduce a polyalphabetic cipher, because the transformation at different time indices is governed by different key, right? So with the Caesar cipher, every time you only apply one particular transformation, or even affine transformation. There's only one key acting. But with when we have a polyalphabetic cipher working in a block, then it's actually, as time changes, there'll be different alphabet, different key. So this introduces some complexity in the substitution, and that also makes the job of the cryptanalysis that much difficult. Okay, so this is the modern. Then using that we went to modern ciphers. So for example, so the physical cipher we discussed is like this. So for example, it's a block cipher. Then input will be viewed as a sequence of n-bit blocks. Then each n-bit blocks is processed the following way. You have so for a key, from key you derive some r different round keys, and for each round key, what we do, first we divide into two portions. And for the second portion, use that the right portion as one of the key, and the key for that particular round. Then you XOR with the left, and that you put it in the right, and then simply right you change it to the left. So the changing from right to left is a kind of a permutation introduced in this one, and then the use of function f it also introduced kind of substitution. So in one round, you have a sample of a substitution and sample of a transposition, and you do several rounds. So this thoroughly changes the the output of the cipher. So which bears no relationship with its input. Correct? So this is what. So we had a workshop on that. So maybe you have to go back and look at your work and familiarize yourself with this. Okay. Then we also discussed the modes of encryption. That became very important. I think we did. These are the modes. Why do we need modes of encryption? Why do we need modes of encryption for a block cipher? Sorry. Why do we need modes of encryption? Tell me. Reasons for having modes of encryption. Anyone answer? Pardon? Different sorts of data. What data? Sorry. Yeah. Yeah. It's a good idea. See, look, what block cipher does is it takes only 64-bit information, transforms into another 64. But in day-to-day life, we have opportunity. We have different situations. Sometimes we have to encrypt a long file, where if you take 64-bit, the file may repeat. So if with a block cipher, if you have the same messages getting in because it's the same key, you'll get the same output. Now you want to have some kind of authentication that of encrypting all the blocks in sequence. So when you have such cases, so you use you use different kind of modes. For example, electronic codebook mode can be used only for protecting short information like passwords and everything. But and passwords have a low entropy, right? Now, but how do you now use it to encrypt a longer messages? So those are the things that the reasons for using this. So here there are so many things to learn. First one is why different kind of modes. In cipher block chaining, you actually use the output of the cipher as an input to the thing again, the next stage, and hence all the encryptions are somehow coupled. And so with this, if you are able, I asked a question, if Bob decrypts it, how does he know that he decrypts correctly? So as long as he doesn't see any format violations, with even with all this cipher block chain, then he gets the overall authentication that he has decrypted properly. So for some of them, cipher CBC and all, they are naturally geared towards adding some kind of authentication also. And then there are other ciphers like CFB, OFB, and counter mode. They're used like a stream cipher. Stream cipher means you've got a stream of information and you create another stream of code, like a cipher code, and use XOR with the message to get the output. The cipher feedback and output feedback combines plain text into cipher text in a particular way. And those are specialities we discussed it, and there were questions also in the mid-semester test. So this is extremely an important part, and you have to review it. One way to it's not just reading something, you need to read and understand. Questions will be mostly if you know the answer, you will be able to work out. If you know the ideas or the concepts behind it, you will be able to work out in the exam. Okay, so that kind of a thing is there. So there's no need for rote memory, but if you all these things can be learned by associating these concepts with with some ideas for yourself. So that way you can remember them much more easily. Yeah. So in fact, so this one here it tells you, for example, the typical application. This one slide actually summarizes the different properties of modes of encryption, and so for you go through each of them and keep some memory. What will happen. For example, if I have a cipher block chaining, and if some error happens to the output of a cipher block, how it will get decrypted. So you can follow those kind of questions. So just clue on and look at the chapter, and so you should be able to answer it. And look at the corresponding workshop questions, and those things will make things clear. Okay. So then we went to public key cryptography. I think that's where we have already discussed so many times. I think the main concepts we discussed was Diffie-Hellman, and also the man-in-the-middle attack for the Diffie-Hellman. So at the end of this, you should be able to explain why Diffie-Hellman algorithm is vulnerable to man-in-the-middle attack. Yeah, can you? How many different versions of the man-in-the-middle attacks we considered in the subject? One is for Diffie-Hellman. What's the other one? You can also have a generic public key. Public key means you choose some private and say that this is my output, this is my public key, and exchange it to the other person. Other person also, he has private key and he exchanges the public key. And after that, they can actually exchange some information over using each other's public key, and then create a key which is some function of the keys exchange. Now this is equivalent to above Diffie-Hellman thing, but still vulnerable to man-in-the-middle attack, because public key, when you say this is my public key, there is no way I can you? How many different version of the man-in-the-middle attacks we considered in the subject? One is for Diffie-Hellman, which is the other one. You can also have a generic public key. Public key means, you choose some private and say that this is my output, this is my public key, and exchange it to the other person. Other person also, he has private key and he exchanges a public key. And after that, they can actually exchange some information over using each other's public key, and then create a key which is some function of the keys exchange. Now this is equivalent to above Diffie-Hellman thing, but still vulnerable to man-in-the-middle attack, because public key, when you say this is my public key, there is no way I can authenticate that this is mine. See, if I say my public key, it looks quite random. How do you know that it is mine? Unless, of course, I give you personally, or you are convinced that this has come out from me. Yeah, maybe through an email which you have sent me earlier. So you can get only with these kind of features. But on an internet, when you get a call, you don't know the other person is. Right? So public key can be randomly instantiated and decided. That doesn't mean anything. So another concept that we looked at was basically authentication of the public key itself. And that's what we worked with the protocols later in the chapter, like in the later week 7 or week 8. But initially we went through in detail how Diffie-Hellman protocol works, how RSA algorithm works, and we have lots of questions with this kind of things, and you have to be ready with answering, like go through, and questions can be from that. And this figure actually illustrates that idea of a public key. For example, you can see here, Bob, he has a public key of Alice, but he also has a list of other public keys that he has acquired. So whenever he wants to encrypt, he takes the public key of Alice and encrypts a message and sends it to Alice. Alice will have private key and she can recover. Similarly, you can also actually convert the same encryption algorithm with private key, and hence you can create some kind of a signature, because here you can use, for example, Bob, he takes his private key and makes transformation, and anybody who knows the public key of Bob can actually decrypt it and obtain the plain text corresponding to that. So this way, you can also have some idea of a signature thing using so if you use public key, that's for encryption. If you use private key, that is for signature. Now this concept, there should not be any confusion, and you should be clear about it. Is that clear? Yeah. And this is the Diffie-Hellman protocol. So for example, given a particular group or generator, and assuming that the discrete logarithm problem is hard on this one, you can have a Diffie-Hellman protocol. You can also, as I mentioned, you can also have another type of Diffie-Hellman protocol, another key exchange protocol based using only any generic public key. Yeah. So those two ones you should be able to you should actually define and exchange. This is clear? The Diffie-Hellman key exchange, at least? Yeah, I don't need to go through. RSA public key was also mentioned, because in RSA, why does RSA scheme is secure? So that's like for example here, from the private key, you can easily compute public key. From public key, you can't work backwards and find the private keys. Yeah. So in RSA, what's the public key? E and N is a public key, and D is a private key. So E times D, that is the inverse of each other, so they had to be equal to 1 modulo phi of n. This phi of n is the fact only known by the person who created these primes, because n is PQ, if n is public, if somebody can factor it, then they can also compute phi of n, then RSA will not be secure. But factoring is a hard problem, hence no one can do that. Yeah, and why RSA scheme encryption works, because phi of n, which is the order of the group on which you do the exponentiation, this is secret, because only the person who has the private key, he knows the order of this group. Others don't know. Others simply take some number and use the public key given by the user, and they take m to the power of e mod n. Correct? So this idea, I gave that intuition how RSA people done. That's probably an important thing to kind of study and make. So you can make a cheat sheet with all these kind of formulas, and then you can keep browsing it, for those kind of things for the study. So, and now when you use RSA, so can RSA be used as a signature algorithm? Okay. Yeah. So this concept was discussed. Yeah. So and we show that RSA is not like a basic textbook RSA is not secure for CCA. And these concepts are very important. So here, for example, the signer. So you take the message M, and you have an RSA at some kind of a RSA function. Then you get M S. The signature S is the m to the power of d mod thing, and then you use the S dash. You use the decrypt it. With a verifier, he uses this. So, for example, here the public key. So, private key. This is RS. Alice uses the private key, and Bob can use the public key of the RS to get back the message, and he will check if that this can only be done by the Alice who has a private key, which is D in this case. So, I mean, this particular simple digital signature scheme is vulnerable for blinding, and we went through that one, which is basically followed from the very simple fact that RSA function is a multiplicative. That is, if you have take an RSA function on M1, RSA function on M2, that will be same, and you multiply that, it will be same as RSA function on M1 times M2. Now, as long as this is there, so this is also a multiplicative property. It's kind of homomorphism. So this is actually a useful property, but to convert it to signature, we make sure that we don't sign directly a message, we assign the hash function. So please go through those lectures again and understand these concepts. And also, that's the one which actually uses the things. So which means which led to the requirement that we need kind of a hash function, and hash functions has set of properties. So here we discussed a lot actually. We had an assignment question, and in fact hash and MAC they share similar properties. So hash function is a symmetric key primitive. False or true? Hash function is a symmetric key primitive. Is it true or false? Come on. Come on. False? True? So when you case symmetric case, the thing means what? For creating and verifying like hash, you need a same key. But hash functions, do you have a key? It's unkeyed primitive, right? So it's not a symmetric key primitive. Whereas MAC is a symmetric key primitive because for creating a MAC, you use a key, and the same key is to do the thing, right? So this distinction is very important. Is that clear? Please read through the corresponding sections, okay? If you don't answer, I will, it won't be good because I won't go as a happy man afterwards, So you should. So is that idea clear? So hash is it's a keyless, unkeyed primitive. But whereas, and using unkeyed primitive, we show how you can get a keyed primitive, right? So because you can have a message and you can put a key and then run the hash, then nobody can repeat because nobody knows the key, so they can't verify. So you can actually, so MAC is actually a keyed hash function. Hash is a unkeyed primitive. MAC is a keyed hash function. But of course, you can use a generic hash function itself to create a MAC and vice versa. All that thing we discussed. And the structures used for same structures and we used it for creating hash functions and MAC functions. Right? Okay. So even assignment had a question on MAC, so please read through the hash and MAC thing. Now, what are the properties of the thing? MAC is there. So here you can see that like all the relationship between the second pre-image resistance and third resistance and pre-image resistance. Yeah. So you go through and with some examples and learn all of that. Okay. Then the key management. Then we come to the key management. So now at this point of time we are equipped with all necessary public cryptographic primitives. Then we want to create it to user using and that's where the key management thing came. So and the key management cycle is so for example Alice and Bob, if they need to have a common key, how do they get the common key? Then these keys are to be acquired from a key distribution center, and key distribution center actually online and this and Kerberos is one of the applications that actually built out of this one. And we also have a kind of key management lifecycle. And the important thing that we learned was this is the Needham-Schroeder protocol, which two users who have not they have. So in this case, both users A and B, they share some key with the key distribution center. A shares Ka, B shares Kb, and if they want to have communication, what are the steps in obtaining keys? This is clear, right? Yeah. So this is what is something that you need to work through it. Now there's also another one by using only public key cryptography, you can actually get a common key, right? So if A and B wants to get a key, well, A can initially tells it is my public key, and B cells actually gives the secret key with his one, and at the end of that the both will get a session key. Is this key secure? Is this key management thing is secure? Or does it is vulnerable to management attack? Yeah? Yes. Why? Yeah. Correct. So let's say a man in the middle, from A and B, one person he can catch his PUA, and he can change.
A generates a public key pair PUA PRA, transmits message to be consistent PUA and an identifier of A. B generates a secret key KS and transmits it to A, encrypted with A's public key. It computes the decryption of PRA, PUA, KS to recover the secret key because only A can decrypt the message, only A and B will know the identity of KS.
Is correct. So let's is vulnerable to man in the middle attack? Yeah? Yes. Why? Yeah. Correct. So let's say a man in the middle, from A and B, one person he can catch his PUA, and he can change his middle and send it to B. B thinks that it is coming from A. So and the man in the middle will get the keys. Yeah. So now, will you be able to write down how this is vulnerable to man-in-the-middle attack? And those are the things that you should be learning. Okay. Yeah. Yeah. No, that's also true. But yeah. So this is a very good point and very nice one. Here, a man in the middle there. But look, but he may. It's about then you can contact with A, but then you have to masquerade as B for that purpose. But if your purpose is to come in between and pass on the information from A to B and convince both A and B that they're talking to each other, that time he needs to know the B. Man in the middle attack is actually targeting communication between A and B. So in that sense, he has to continue. But if he wants to just to masquerade as B, he can do. Because then the A thinks that he's still talking to B, but let us say B has some information, right? Let's say A and B, they have other information. So and it's very difficult for the person in the middle to masquerade him as B all the time. But if what he does is he'll ask question whatever A says, then he repeats it to B, and whatever B answers, he relays back. So this way he can be in the middle and just keep watching the fun. And when at the crucial point he can break. Yeah. So man in the middle. So those are the special things that we learned. Man in the middle attack, and this is extremely. I mean, how can you avoid this man in the middle attack? Tell me. I'm going to simplify. How do you now thwart the man in the middle attack?
Security center.
Pardon?
The security center these people
security?
Center. Also probably lights which public key is which.
Yeah. Basically, security. I mean, how do you like you need to tell me there is a security problem I know, but how do you really overcome it? Time verification. So, but unless why is this kind of attack was possible in the first place? Authentication was absent, right? So you have to introduce authentication. So how do you introduce authentication in this subject? No, using nonce. Well, I mean the man in the middle also can create the nonce,
KDC.
So how with another function, even with another function, if that is repeatable by the man in the middle, he could do that as well. Signature is good, but signature requires public key. But how do you know the authentication of the public key? Same problem. You want to authenticate one encryption, but you use signature, but signature is public key. So KDC usually what is done. KDC means then you have to be all the time you have to be with KDC. KDC is a symmetric crypto system, right? It might solve, but then the public key cryptography is there because you can actually get a common key using only public information. But now you already for the authentication you still need another person. So that's why we discussed about in the public key authentication scheme we get certificates. Certificates are the only way. Okay. Because when let us say that is certified, it is signed by some third party with whom you also believe. Okay. Without which you will not do. So using nonce and everything is only making all this protocol a bit more freshness of the key and other things you can introduce. But man in the middle attack you can't do. Right? And because in all those KDC schemes, each user shares one key with the KDC. And obviously when the key is delivered to you, you know that it is given by KDC. So all those things are there. But in a public key cryptography, man in the middle happens because of their lack of authentication. Okay, so do you? I mean, so there is a question about, let us say, man in the middle attack and other things, and you don't come to your answer is nowhere near about putting the authentication part. Tutor will not give that mark. Okay, because why the man in the middle attack is happening is because of the lack of authentication. How do we do the lack of authentication? Is through the certificates. I think that's the important takeaway from this discussion. See, one discussion. That's why if you ask questions, it will be more interesting. Of course, all the things in the freshness of the keys in the key protocols we discussed, they are important too. There, it's about this protocol. It's not the protocol message you receive is fresh, and it is not a repeat of some other things like a storage of past things. So they, and in such environment, say for example, where that first search will happen is like when you are now opening your computer. You are already logged in. You are within the computer. There are lots of different entities. You have a print server, you have a file server, you've got all those things. And they all should give you the service because after you have put the password, right? Once you put the password, the other keys are generated as a part of, and so the protocols that we discussed in Needham Schroeder comes in that thing because there's one domain where that's already authenticated, that kind of thing. Whereas the man in the middle attack in this case comes in the, for example, communicating with the server. And how does server know that he's only talking to this particular one. For that, you need to have a certificate of the server to verify that it's a right server. So that's why you have HTTPS compared to HTTP. So so man in the middle attack in this subject, at least from the exam point of view, we will be studying mainly for the public key cryptography. Okay, at least is that clear context? And then you study the solutions to that. Huh? I think there is actually.
Okay. See when no time. Right, time to have lunch. I'll have lunch. I'll have a shower, and I'll be back. So at most 40 minutes, 45 minutes. All right. Cheese fest, no breaks. Yeah. Will suck. Man's gotta eat, what can I say? I'm back. However, I'm going to reconnect my camera here. It's good. Hold up. So it's kind of connected. My right screen is green though. Don't know how to fix that actually. Oof. Let's have a look. Pause, resume. Pause, resume. Maybe disconnect. Maybe reconnect. I have an idea on how to fix this, but it just means I have to restart for a bit. Okay. Gotta close and reopen. Give me like 5 seconds. Okay. Back at it again. Okay, it's fixed now. After a reset. What's this? More. That helps. Delta. Is this troll? Am I being trolled? I'll definitely have a look at this in detail. Could be, it could be wait. Household providers, homeless. I don't even know. I don't even know. homeless shelter, is it not? Right, so look, I want to try doing this problem, but it will be a little difficult given that I don't know, I guess I'm not confident enough with knowing exactly what to expect. Not moving. So we will try our best here. So we're gonna go adjacency list. Now an adjacency list, we're gonna say ADJ is equal to some set of characters to set for word in words. So for W in words, for C in word. Now the result set we're going to reverse the result. Is it reversed? Yeah, reversed. And we're going to return the join of the result eventually. Now, there's going to be two parts to this. First part is to create adjacency list. You create the adjacency list what else? We're looking for the node before so in the adjacency list for word in words, for C in word. Okay, it's not for C in word, for word in words. Okay, it's not even for word in words, it's for the comparison between word 1 and word 2. Now, we're going to say these are going to be indices. So if they're going to be indices, we're going to say for I in range of word, so len of words. Now we're going to -1 because you're going to be comparing two words. Ooh. Ooh. Give me a sec. Damn it. I wasn't speaking this whole time. Damn it. Ah! Yeah, thanks, man. Thanks, Mohit. Hello. So, I mean, here's the thing, right? So how do you manage Leetcode, web dev, and college with Jim? So here's the thing, right? Leetcode, that's just something I'm doing consistently for now, but not always. We got Jim, that's only most days as well, but not always. But, you know, web dev also, I've only just recently picked it up again. So with all that said, I do keep a track of what I need to get done in the day. So I try to make it as doable as possible. Now looking at this, you know, I already had lunch, had a shower. I'm changing this walk to a gym actually. So I'm changing this to gym. I'll gym in the next hour after I've done possibly the rest of the exam paper questions. And so I don't know, it's just keeping track of the stuff that you do get done during the day and knowing what you can get done. That's the biggest skill I think you got to learn. At least that was the thing that I had to learn the most about, which is timing your days correctly. What is that application? It's called Things 3. Okay, but the thing is, it's too expensive if you really think. It's like $150 in total, or $130, something along the lines. Do you got any revision tips? Well, you know, I wouldn't say I'm the best at revising, but for me at least, I'm going to be doing lots of practice questions. So that's the main objective. And I'll also be, I guess, for the upcoming exam, the first one in 4 days, I'll have to revise all of these different concepts, and I'll revise them mainly from the notes that I've taken in the past here, all of these, which are just the questions that I would ask myself to I would quiz myself on. And so I'm going to look through these the rest of today and also do this practice exam, which is this one. Or is it here? Still got a few pages to go through this one, but once I do, then, you know, it's just all about doing practice problems, just like what I do with Leetcode, I think. So just do practice problems continuously. Okay, so this page is done, but now we can move on to these problems here. Okay. Right. There are a few checklist stuff here that I was told. Kind checklist to help you prepare for the exam. Please ensure you have finished the re-review of all the lecture contents. Be clear with the definitions, properties, workflows of each concept. All the tutorial contents. Ensure you solve them individually and efficiently. Question and solutions for assignment 1 and assignment 2. Questions and solutions for mid-semester. Weekly quiz and the practice exam. Now, I did all the weekly quizzes, did the MST, but I could review the solutions for the MST and the assignment 2. So the 1 hour consultation is at 11 AM next Monday. So that's going to be useful, which I should be able to attend. 11 AM, so this is just a copy and paste up to the next week. So this is an online consultation. Oh, wait, it's always been on the 28th. Okay, never mind. So I never really missed it here. Just always been on the 28th. The past project, so the project report will take a longer time to mark. Ruse mark will be released after the exam, however, it will not influence your exam. By the way, the university at the end of the semester, blah, blah, blah. Okay, that's fine. What are these? So a general reminder of completing this will help us receive the impact. Or complete your end of year survey. You can follow the link to directly access. Thank you, Adrian. Didn't need that. Hi everybody, there's a showcase of some interesting AI projects by UNML research and academics who might be interested in viewing, which will be held at the Cremorne Tech Showcase. If you're okay or interested, attendance is free. Short train ride from UNML, interesting. Actually, might be interested. Okay, let's try and finish these questions in the next hour. We'll try to understand them to its entirety. So in order for me to do that, I will need to close some of these tabs I'm not using. Now is this the same? It is. Close this one as well. Oh, let's reopen that one. We need that one. Close this one. Close this one. Close this one. And this is the alien dictionary problem. Okay. Let's go. Okay, now, here's the thing. I understand that, but this is a little bit harder to understand. Explain how to use a block cipher in CBC mode to create a hash function algorithm. Refer to the lectures, workflows in lectures and books. Refer to OFB workflows in lectures and books. Explain the workflow of Diffie-Hellman key exchange process between two parties. Refer to Diffie-Hellman workflows in lectures and books. Refer to forward secrecy in lectures and books. Like, look, fair enough, you know, they're hints. Hash function. Now this is the actual problem question that I want to solve. But to be honest, this part, I should probably do this properly. These parts will need to be looked at closely as well. So if anything, I should go through these and understand these first. So, alright, let's do that. The answer was C for confidentiality. Okay, so this was C. Okay, so I can do a yes. So I said least certain. Put it on this side. And I'll put the dash, which is actually indicating that it is the correct answer. Put this on a new page probably. Have a look. So whoops. To deploy a secure RSA encryption system, we want all of the above, so that's correct. Digital signature, have a look. So no other information on it, so it's fine. So MAC, master key, the encrypt of OGAML DOA set B. Okay. Alright, let's have a look. Understand these better. So, right, so I might put this on a new page as well. So we technically have 3 pages. Alright, now so which of the following statement is not correct in symmetric key encryption? Confidentiality and authentication cannot be simultaneously achieved. The same key is used for both encryption and decryption. That's true. The key needs to be strong in order to ensure confidentiality. That's true. Confidentiality and authentication cannot be simultaneously achieved. With symmetric key encryption, that's incorrect. Right. And the sender and receiver must share the algorithm and the key, which is also correct. And I said none of the above. So confidentiality and authentication cannot be simultaneously achieved. The problem is I can't think of a reason why it couldn't. Wait. So which of the following statements is not correct? So confidentiality and authentication can be simultaneously achieved. In what way? Confidentiality and authentication. You know, what is the basis of authentication? why can symmetric key encryption? Data appended to or a cryptographic transformation of a data unit that allows the recipient of the data unit to verify the source and integrity of the data unit and protect against forgery is a digital signature. Now, what is a security audit trail? Okay. I don't need any. We can just copy this dictionary solution. Then copy this, maybe paste it here. Don't actually want that. Wait. Encipherment. I see. An authentication exchange. A mechanism intended to ensure the identity of an entity by means of information exchange. I guess, yeah, that is also pretty straightforward. Like, I've known this. Like, it could be transferring nonces. So that does make sense, such as and what is a MAC? Now this is where I could look into Macs a little better. So Macs are up here. Hash functions. Where's Macs? This is fine. Probably move this here for a bit. So attack on hash functions. These are the different ways to attack hash functions. And in general, hash constructions, Merkle construction, birthday attacks, message authentication codes. This is where it becomes interesting. So message authentication codes. Let us look at message authentication issue in practice. What is it concerned with? To address message authentication, a dedicated primitive based on symmetric key cryptography. Yeah. Symmetric key cryptography. Message integrity, validation of originator's identity, non-repudiation of the message. 3 ways of achieving authentication is message encryption, hash functions, and message authentication codes. So message encryption, I can kind of get again. Message encryption might maybe just encrypt the message. And then the other person can decrypt the message, right? Obviously. Hash functions, where you can use a message, take the hash of it, append it to the end of the encrypted message, and when you decrypt it, you can see the hash is the same. So was that a signature, right? I should expect the previous lectures to have talked about like signatures, perhaps. Is there integrity in the active setting? In an active setting? Classification. Hash construction methods and attacks on the construction goes hand in hand. Cryptographers work hard to find good methods. Cryptanalysts work to break them. NIST invited researchers to come up with hash proposals. Having a secure hash function is still an open question for researchers. Here I will illustrate a simple method based on the block cipher construction mode. It is also sometimes referred to as the Merkle-Damgard construction. Heart of the construction is a compression function. Messages are arranged in n-bit blocks with possibly the final block padded to match to make the message length multiple of n. The size of the hash is n. The Merkle-Damgard construction, you have some padding where you have n bits finally, n bits originally. You pass this n bits into a hash function, and then you continue to pass it through more hash functions. And compression function, n bits times n bits. So n bits could just be So from this at least, the Merkle-Damgard, the key of it is some function that takes two bits, like string of bits as inputs, m bits and n bits to get m bits. Sure. Yeah, that is the main part of the function. That's the compression function. Merkle-Damgard construction is a compression function, or has a compression function. Yeah, so I think that makes sense, but Merkle-Damgard is something I will say. Okay, so how do we create message authentication? We need to separate message authentication function and the protocol that helps us to integrate the message authentication in the application. At a basic level, we can create a message authentication code using a secret key. At a high level, the keys are carefully managed to obtain high-level guarantees of the exchanged message, including source authentication. Grind mindset for sure. Just send me a LinkedIn, man. So the security requirements. There's encryption. Gotta understand these well. So how do we create message authentication? Alright. Hash function, Mac, gamma. Alright, hash function. This is for RSA. So Mac, chosen message attack is applied to forge a Mac depicted in 1. Let K be some randomly chosen MAC key which is unknown to the attacker. In the game, we allow the attacker to request tags for arbitrary messages. So be aware of tags, like what tags are in Macs. What's it called? Merkle DamGuard uses a special, compression function. Gotta remember that you take as 2 inputs, some M bits and some N bits to get the output of M bits. Remembering that. Also to memorize is the way in which we construct and find the probabilities of the what's it called? Nash equilibria or AI planning for autonomy. What else? Can't necessarily think of anything else at the moment. Okay. Let me get a drink of water. So, how do we create message authentication? We need to ensure message authentication function. We need to separate message authentication function and the protocol that helps us integrate the message authentication in the application. At a basic level, we can create a message authentication code using a secret key. At a higher level, the keys are carefully managed to obtain higher level guarantees on the exchanged messages, including source authentication. Source authentication. Yeah, source authentication. Remember that, I guess. Source authentication, that is coming from the correct source, I think. Okay, first let's understand how message encryption itself provides authentication. The issues are different to symmetric and public key methods. Note that with public key encryption, anyone could encrypt based on public key of the receiver, and if you want source authentication, the sender needs to use signature. Yes. But symmetric key assumes that the sender and receiver share a secret. Yeah, and encryption naturally provides authentication. Yeah. Yeah, sure, that makes sense. So stallings, because authentication by definition is to ensure that you're connecting or talking to the right identity. It is assumed that if you have a secret key, a mutually shared secret key, then you know that you're authenticated with that person. And you can source authenticate by using digital signatures in public key cryptography. Is there such thing as destination authentication? If there was, I mean, there is no destination in public key cryptography. Just everyone throws out their public keys, so that's fine. How do I send my ID? The bot is removing it. Just connect to me on LinkedIn in the description. I got a link to mine. I got a link to my own LinkedIn in the description. Let's first consider symmetric encryption. So how authentication is obtained in symmetric encryption, since they share the key, the receiver is sure that the message was created by the sender. That's authentication. By relying on format and structure of the message, they can detect any modification. Next, we consider other situations. So the message encrypted with a key gives you message authentication, and thus the encrypted message, and you can decrypt it. So symmetric encryption, confidentiality, and authentication. Yes, I agree. Okay, basic use of encryption. John Doe. Would you say streaming helps stay consistent with project/homework? Yeah, for sure, like 100% it does, I will say. So it really helps me keep on track personally, and having like accountability just by the people that watch. And if it's not the people that watch, that you might watch in the future yourself, so it's the future people that watch as well. Who knows, maybe you want to keep a backlog of how your life progresses, and when you look back in the future, you'll make sure that every piece of time that you spend now is gonna look good into your future. Well, is gonna look good when you look back at it from the future. So yeah, keep yourself to a high standard now by having it recorded or something, and then just posting it out into the world. John Doe. All good. Next we consider other situations. So if we have source A, destination B, read the discussion around Fig 1.2.1 in the textbook. Alright, well, so you're saying, just looking at this, confidentiality and authentication, public key encryption. Yeah, that's pretty average. Public key encryption, authentication, and signature. You put the private key encrypted with the message and give it to decrypt with a public key, right? Yeah, so that's authentication and signature. But the other is confidentiality, I agree. Right, so public key cryptography kind of separates confidentiality and authentication. Prem-bished. Not getting job, what you mean? Why do you think you're not getting job, man? Don't feel demotivated, you know? I mean, what have you done? You know, what have you done so far? But look, I definitely know what you feel. I felt the same before. Just know, life does get better. Even if you think it doesn't. Need that housing. That's the type of housing I can afford when I get into in this economy. Okay. What are we thinking? Isn't it ROB? Wait, no way. What? Yo, he's just not gonna be in the same room? Wait, no. No way. Let me check mine. My.unimelb. Exam. Sleep workshop, love it. Oh, this is actually like... This would be kind of cool, not gonna lie. Might be kind of cool, to be honest. I'm getting sidetracked. Let me actually... Oh, there's an online session. Wait, online sessions Tuesday. Tuesday 24th. What? Okay, you mean Thursday 24th. This is an online session and this is a Zoom session. No, they're both Zoom sessions. Oh, well, I thought it would have been an in-person thing. That would have been fun. I would have liked that, but alright, fine. I'll just book it anyway, because why not? But this is, let's have a look. So, this is for my exam. No, that's not what I wanted. My exams. Yes, yes. So it's the same time, it's just different. Clash venue. Three to 5 p.m. Oh, it's meant to happen right now. No, I don't want to do it right now. Select this one. Well, okay. Taking a while. Booking has been confirmed. Alright, close. Close. PRPU, confidentiality, authentication, and signature. PRPU, confidentiality, authentication. Private of A, public of B. Use private of B, public of A. You get the message. Confidentiality, authentication, and signature. This could be pretty useful discussion indeed. Public key encryption. Public key by nature anyone can use, does not provide any guarantee for the sender. To provide authentication, a sender needs to sign as well. Use private key, which can be verified by others using the public key. How do we decide if the message stream is corrupt or not? You need some general formatting rules. Confidentiality, authentication, yeah, okay. So this is where message authentication codes come in. A dedicated primitive to address mainly authentication using a key. So the output of an algorithm can act as a signature. Now, only the receiver with the key can verify the code by running the same algorithm, thus assuring the integrity of the message from the sender. There are two ways of using the message authentication code: internal error code and external error code. So this is what a MAC is? Maybe? Oh no, this is internal, external error code. But this is important concepts. So some tag where you concatenate with a message. MAC use in practice. A pair of TCP hosts shares a secret key and all exchanges between the hosts use the same key. Leads to simple encryption between hosts. All IP packets between them can be encrypted except the header. Formally, MAC is dedicated symmetric key primitive aimed at providing authentication with encryption. It can easily integrate to provide secrecy. They are useful when in some applications you only need authentication. There are many situations where the property of authentication requires longer than confidentiality. Authenticated sessions where only at times you may exchange secret information. MAC is different to signatures. The MAC has many properties similar to hash. MAC is equal to the MAC of a key and a message. MAC is a keyed hash function. You can treat it as a cryptographic checksum digest. It takes an arbitrary length message as input and outputs a fixed length authenticator using a key. Checksum digest, it can take an arbitrary length message, fixed length authenticator, yeah. Like hash functions, many want to function with pre-image resistance. Satisfies hash function properties, so sometimes MAC is referred to as a family of hash functions. So MAC is a family of hash functions sometimes. Attacks on MAC: brute force attack, minor collision. For cryptanalysts, there are two approaches. Attacker can first determine the key that he produces MAC value for. Interesting that he can just try to determine a valid tag for a given message. Similar to hash functions, you realize that MAC has to have a certain length to defeat brute force attacks, and generally try to create new MAC functions using existing hash functions. MAC based on hash functions. Now, we do not study construction of MAC in detail. It is sufficient to think of it as a keyed hash function. MAC based on hash functions are popular in practice. So what is the difference, say, with a MAC, which is a keyed hash function, and a digital signature, where when you sign, you have some message and you have some key, you know? Simple protocol, keyed hash, hash message, concatenated with a message, with a key. Some weaknesses were discovered using the simple proposal, which led to the development of HMAC. It's thoroughly studied in literature. The textbook explains the concept in some detail. Please go through the discussion of the textbook. Now, just have a look at it. So, William Stallings. Now, 12.5 is what we're looking for. Next, based on hash functions. Yeah, it's a hash function, MD5. Okay. Fine, that's cool. Pseudo-random generation, and as opposed to random numbers, pseudo-random number generation takes a seed value as input and generates a sequence of digits. Like hash, for the same seed value generates the same sequence. We briefly look at the topic and consider some pseudo-random proposals based on hash and MAC. Seed, counter, pseudo-random output. Okay, well, properties of MACs, different error controls, yes. Message authentication codes, now internal error code and external error code. So MAC, I gotta go to the MAC section. And what is a MAC? It's a keyed hash function. What are the two error controls in MACs? So what are the two error controls in MACs? Oh, it's just gonna be this. Gonna be this. Copy a link from, paste. Okay. Nope, that's wrong, actually. That's wrong. Not right. It's not pointing to the right spot. No, that's not right. Probably copy area. What would I expect? Not working. Okay. Maybe I'll close that and reopen. Link. Go back. No, it's the same thing. It's the same thing, man. Not really working. The linking. Alright. That's fine. Okay. Cool. Time to go for a walk. I'll be back. I'll be back in around 30 minutes. Just gonna have a quick walk. tonight. When's your cryptography exam? My cryptography exam is in around 5 days, so next week Tuesday, that's the day I do it. So we prep. Okay. I should also spend some time today just reading. Sometimes my mind needs healing, and I think that would be good when I just spend some time reading. So at some point I will end up reading. Don't judge me the book that I read, because it'll be interesting regardless when I get to it. I'm gonna close a few tabs. Something. I don't think I am. Max are keyed hash functions. that is max key message max take an additional key input to get the output. Consider a version of the practical RSA signature algorithm discussed in lectures. Let N E be Alice's RSA public key and D be Alice's private key. The signature of the message M. Right. Yeah, okay. The verification equation. A researcher discovers that the hash function used in the above scheme failed the second pre-image resistance property. What are the consequences of the collision resistance property of the function and the security of the signature algorithm? It failed this. What are the consequences of the collision resistance property? Insecure. Resistant anymore. So chosen message attack is applied to forge a MAC. Okay, now there's information here about this. So in the different error controls, Oh, hello. Oh, hello tonight, actually, you're back. Have you ever taken any 8-week courses? I've taken 4-week courses. And that's about it. Nothing 8 weeks. Particularly. Daily fact, I'm probably just unfollow your channel. Four weeks is crazy. How many hours a day did you study with a 4-week course? Well, since it was only one of them at a time, I could just focus solely on it. And it was like it was a breadth course, so it was pretty easy. It was like music psychology, right? So it was pretty fine, really. It wasn't, you didn't have to spend 8-hour days or something for that. You could get by without worrying too much. Yeah. Concatenate with the message, encrypt. Or you encrypt, then you concatenate with some message, right? Or you concatenate the encrypted text with a function, then you compare before you decrypt. Now, what difference does this make? We'll see. Anyway, so let K, so chosen message attack is applied to a forge, a MAC. Depicted in 1. So what adversary, MAC challenger. Okay. How do graduate level courses go about exams? Are there any practice tests? Are you on your own? Excluding lecture notes / recordings. Yeah, so like graduate level stuff, there's like 2 components. It could be doing more research, or you could be doing more coursework. And I chose to do more coursework, so if we're doing more coursework, we also do get examples or exam prep material. And in this case, it's just one exam paper that they give you. And I'm doing this right now, actually. This is like a practice exam paper that I'm doing. But apart from that, you know, learn from the lecture slides, your notes. But yeah. So let K be some randomly chosen MAC key which is unknown to the attacker. In the game, we allow the attacker to request tags, where tag I is equal to SKMI, so the signature with the key and some message for arbitrary message I of its choice. So the K is some randomly chosen MAC key which is unknown to the attacker. The signature is public, the K is unknown, the M is public, or well his, and the tag I is given to him. So message I of its choice, we refer to such message tag pairs as MITI. Yeah, that the adversary obtains from the MAC challenger. Using the chosen message attack, the attacker then needs to come up with an existential MAC forgery. Existential MAC forgery is interesting. Existential MAC forgery. Now, i.e. the attacker needs only to come up with some new valid message tag pair. Message tag pair. Right, obviously that's just the message tag pair. Where MT cannot be any of the MITI. We say that a MAC system is insecure if an adversary who can mount a chosen message attack can create an existential forgery. Show successful a chosen message attack or the following. Yeah, okay. Yeah, okay. Well. Hello, Manas. Good afternoon to you. And good luck, thanks, I guess. Okay, for a message m is equal to 1, for a message m is equal to 1 to mn, mi is a message block of length L. Or is that of length 1? It's 1. L. Length L. Is that 1 or L? MAC is generated by secret and S is the MAC. So it's the XOR of all the M's XOR'd with the K to get some secret. Ah, okay, Manus, all good, all good. I'll connect with you. Do you start stream at the same time every day and study for the same amount generally? If so, I'll have to keep tuning in when I'm studying. Yeah, I'll be around. Usually anytime between 8 AM, like consider what time it is now, it's 4:20. But anytime between 8 AM to 11 AM is where I start. And then tonight I'm just gonna finish in about 2 hours. So around 6:30 is when I'll end tonight's stream, but I could go usually for till 9 PM sometimes. So, you know, around the 3-hour blocks between roughly 9 to 6. So show a successful chosen message attack for the following. Now, I guess, you know, you could give a very simple message. Let's see. Could be M1. So M has a message block of length L. So is this length 1 or length L? I still can't tell. It's length L, right? But it's also... maybe it's length 1. Maybe it's meant to say length 1. Oh, David, do you wash your hair every day or in gaps? Your hair looks... Yeah, I mean, the thing is, I do have a shower every day, so I do wash it. It gets drenched in water sometimes. I mean, it does, like, every time. And then, the thing is, I don't shampoo every time that I do have a shower. So, take that for what you will. Maybe it's like at least twice a week, maybe. Or once to twice a week. Do I actually use shampoo? I'm actually considering getting a haircut soon. It's getting a bit long. All good. All good. So for message M to MN, can't say. Get it? Yeah, but I mean, I'll cut it just shorter, but it'll grow out to this length again at some point. My thinking, you know. If I'm doing exams, like my head's gonna be down like this the whole time. If it's gonna be like this, it's gonna be in my face. And so I want to cut it, trim it, so that it's not when I'm doing an exam. Alright, so, okay, this is only one. There's only one question. Now, the question is, how do you create a message? So maybe the message is equal to just M1, where M1 is... I don't know. You want to forge it, right? To create something else. So maybe it's then another message that's... So when you times two of the same things together in an XOR, is that always going to be the identity? XOR properties. Damn, they really don't. Okay. Identity self-inverse. Yeah, it is self-inverse. Okay, this is good. This is what I need. So the K. If you have one message, just M1. Then your S is going to equal to K XOR M1. And if you have just M is equal to K, your S is going to be K XOR K. which is 0, or which is the identity, but you can make it XOR to M1, but you don't know the key, right? You don't know the key, can't really say. So you know what M1 is though. Maybe what you want to do instead is do an M1 XOR M2, maybe. And then you realize that this key value M1, M2, that is going to be combined somehow. So you can, whoa, what the heck is happening? I just deleted that thing unintentionally, okay. So we can combine stuff, right? We can combine the S value. Just by ourselves we can. If so, then we can get maybe an M2, but that doesn't really tell us anything. I guess you want to say your final M has got to be like M1 times M2, or M1, M2, M3. Might be S equals K XOR M1 XOR M2 XOR M3. Or M1. Still thinking, man. It shouldn't be that hard to think of one, and yet it is. So I'll move on. But I know the idea. I understand the question. Okay. Consider the Elgamal signature scheme over the prime field. Oh. GF. So on the prime field GF. This is where it also gets confusing, because GF is stuff that I haven't done before, but regardless we'll read it through. So consider the Elgamal signature scheme over the prime field GF given in lectures. Let H be a public hash function. Be a public hash function YA AXA mod Q. Be the public key of Alice. Let me also turn it down, the brightness here. It's bad for the eyes. Let's use the following equation to define the Elgamal signature scheme. What is the signing and verification equations? Yeah, that's a good one. Okay, but so H is a public hash function. Where XA is the private key, and A is the primitive element in the field. Alice uses the following equation to define this. Okay, well this is also important. Where M is the hash. M is an arbitrary message, and K, S1, and S2 are signature parameters using the scheme. What is the signing and verification equations? What is the consequence of using the same K for signing two different messages? Okay, well we've seen these types of questions before. It's just also hard to remember. Okay, but let's do 7. So the following figure shows an example key distribution method for public key systems. Certificate authority Okay, so the notation here, so this is for public key systems. Wait, where's, yeah. C is a certificate. Message 1 and message 2. Explain what is a public key certificate. It's a public key certificate is something you trust. Public key certificate. Gives credibility to a given identity. Validates of an identity. Verifies the identity of an actor, I don't know. Message 1 and 2. So then explain the purpose of message 1 and 2. So damn it, bruh. Send, I guess, self-identify to KDC as, I guess, CA, right? It's called a CA. Self-identify to CA as a user, as Alice, and the certificate authority would return CA gives Alice a pub key certificate. Must message 1 and 2 be sent before messages 3 and 4? No. Bob can act independently. Since CA only gives back data related to the user, they are identifying as. So that's alright. After all steps are complete, explain why B knows it has the public key that belongs to A and not a forged public key. Also state any assumptions for this to be true. So PR auth I mean, you're trusting that the CA, yeah, you're trusting the CA. Damn, bruh. This is annoying. So consider the following two protocols, Denning protocol and improvement to Denning's protocol. As variants of Needham-Schroeder's protocol, what is the role of T in protocol A? Now, the role of T is just some time stamp, I'm guessing. It is a timestamp that shows when the message, when Alice initiated Does the protocol A ensure the authenticity of both A and B? Does it ensure the authentication? Well, in protocol A, B sends to A and A sends to B. Yes. They use a challenge response at 4 and 5. What is the purpose of sending EKSNB from A to B in the last step of protocol B? What is the purpose of sending EKSNB to B? The nonce NB can be verified by B to ensure there are no replay attacks. Really? This is the exam that we're talking about? There's no, so far, any information on modulo. So, okay, D, protocol A is susceptible to suppress replay attacks. Explain how B addresses this susceptibility. Suppress replay attacks. Okay, suppress, I'm guessing you suppress before you send your goods. Explain how protocol B addresses this susceptibility. So a suppress replay attack would mean that you never get the message when you're at B, for example, or at the opponents, or at the responder. And if you don't get a message when you're at the responder, then you can, as an adversary, ask send the message that you yourself picked up. Cool, but looking at the protocol closely, what does that entail? So Protocol A is Denning's protocol, and Protocol B is an improvement to Denning's protocol. Using not N, well, you use N overlapping with T, and that's it. Let's see. well, let's have a look. Okay, well done, Hao Chen. P minus 1, 5, P minus 1 plus this, just 1 times this, which is just this, which is equal to this. And that, how can you show this is also coprime? How do you show that both are coprime? Is it because P is prime and so all other values will be coprime? Actually, is it because P is prime and so all other values will be all other values okay. So we got 3 updates. That was 1 update. This was that update. So here's what, right? So we've done all of this. I will say I'll give it a break for a second. Turn on my other computer just to do some brain switching. Okay, we're just brain switching for a bit just to give my head a rest. And we're gonna go to scheduler development for a little bit. Okay, so My thinking is we did the rest of the exam paper Qs, but the gym turned out to be a walk now, so actually did a walk instead. We did that. Okay. Rest of exam paper. Eh. Backend app utils. Server host. Server host. Front-end host. Should be fine. Deployment. Dashboard. We gotta go to deployment. Development. and override. Just gotta try all these, to be honest. Like, all of these changes can't be done in any other way but copy and paste. Even with that, where is it changing? Anywhere. Do you find regular music distracting for studying? Yeah, 100%. Even this, like right now, I'm not even listening to it. It's just played as background music for you guys. Yeah, it does. Yeah, it is distracting, man. I mean, sometimes you can use it if you're doing like miscellaneous tasks like what I'm doing. Like what I'm doing is pretty miscellaneous at the moment. I usually play music like either if I'm having a shower or going on a walk. But even still, I sometimes don't think that's the best thing to do. I don't give myself enough time to think independently, think thoughtfully. Do you have a desk lamp? I need one to illuminate just my paper I'm working on. Don't want one too bright. Do you want me to hand it to you over the screen? I can try and light it. I don't have a desk lamp actually, it's a floor lamp. It's like just here, but actually turn it on. But it covers the whole, I guess, table. Just all the way from up here. So Subhem asks, show me your Leetcode. If anything, like if you want to get a good lamp, let me think. The thing is, for me at least, I'm using a Philips Hue light bulb, which can change colors. And I'm not using like an incandescent light bulb, which I've heard are good for the retina because you're not using LEDs, but I don't know how true that really is. And those incandescent light bulbs die super quick and they heat up super quick. It's a waste of energy, I would say, if you go incandescent. But don't go incandescent, probably go just LED, but a Philips Hue light bulb, which is LED and changes the color. So you don't have full-on bright lights 24/7, which is bad for the retina. Now, Subham, I'll show you my Leetcode. I mean, what do you want to see about it, particularly Subham? I'm guessing my profile is what's... Yeah, you can make the colors brown if you want. That's what I use. That's what I do. So, you can make it... I make it like an orangey kind of color, right? So it's like a warm color in my room. So I have another 2 lamps or 2 light bulbs in my room, which I use directly before bed as well, every night. But they can change their colors to fully bright LEDs, or they can be changed to, yeah, like a fire or something. Cozy fire before bed. Wow, I really made this into a checkered pattern. Like, kind of cool. Now I did quite a lot of mediums, which is nice. 0 attempting. I don't get what this means. These statistics there. A rank 1 million. Oh yeah, they're expensive light bulbs. I guess, you know, that's the thing. If you buy them once, I haven't had to switch them out ever so far. So, I don't know. It could be useful, but also there are other light bulbs in the house that we use that are also like as longevity, like has a long life. And they cost a fraction of the price of these, but yeah. Push for rank 1, nah man. I'd be spending day in, day out doing this 24/7. I don't think I have the smarts to or the persistence. Hello, Aryan. Main. I wonder if some of the top leaderboard people on Leetcode just use AI for memes. Yeah, I think if we're talking about the top, some of them probably have like companies such as, what's his name? Devon AI. I think that's fine, right? Yes. David, how are you able to remain productive for the whole day with having distractions? I guess, you know, the distractions come at right times, you know. But I guess there's always, I'm always context switching, I guess. For the better or worse, because right now, you know, if I wasn't doing this right now just to rejuvenate some of my own energy before I get on to my exam prep, more of my exam prep, I'd probably be like not on this stream. Like I'd probably be reading something, or if not reading, just rotting away, maybe. Now that just means like, that's the power of context switching, man. Do something that you kind of like to do. That changes from what you don't really like to do, exam revision maybe. Power of context switching. So, if I'm missing this right, traffic. I have a dashboard. Backend API docs is interesting. Backend API base URL. Adminer doesn't change, but front end, back end do change. And that's a question like, how do we know those are changing? I'd really like to know how you know. Dashboard. If I checked before, sus. It's a bit sus. Backend API docs. Staging. Project. API. I'm just gonna say something like this, but I know it's not right. Okay, I know that's fine. And there's a missing space. It means these have to be right, but I don't know how we can assert that. So we can mark this as viewed, 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 except yeah, can't say. Where? Oh, there. That's where. That's cool. That's cool. And that's the development setup. It changes a lot, so.
Yeah. Sorry.
God damn. It's interesting that so much got changed. Okay, I'm just gonna have to copy this new one and then just change anything that I think is necessary. View file. Bro, what's your Windows resolution? I think 1440p. Yo, this doesn't even mark the viewed. Now it does. Okay, so development, this should be... wait, so deployment, that's deployment, so that's fine now. But development on... yeah, just development. This is where we have lots of changes. Lots of changes. Fortunately, this is how I can only make it work. Or V. Okay. Hey David, currently I have my unit break, so I have a whole day available, but at the end of the day, I end up only being productive for a couple of hours. Rest are wasted like watching YouTube, etc. Any suggestions you got for me? Yeah, so glad you asked, I will say. I guess the first thing is that it's good that you identified that, you know, you're in a sense wasting away, right? Wasting away with quotations on watching YouTube videos. You know, having this mindset is a good starting point, I would say, because you know that you are wasting something, right? And you could be doing something better. But you also have to consider not only, you know, how you can prevent something from happening, but also how you can grow your own motivation for something. So instead of, I guess, looking behind on trying to push things out, try and pull new things in. Now, how do you pull new things in? That's a tough question. And you know, I'm speaking about it in a very what's the word? Metaphorical way, but you want to basically find some motive in your life that fulfills you in some sense. Now, for me at least, this was this app that I'm building. You know, there's actual personal gain that I can see myself having when I complete this task or make this app viable. You know, for me at least, I want to make this app because I want to have an app that I can personally use that does exactly the functionality that I need for like a Todoist app, right? So this is kind of like a Todoist app. It's kind of like Things 3 that I'm using right now, but it's also my own. And because it's my own, I feel a sense of, I guess, ownership and want to make it well. So it's part of my identity almost to do something like this, to actually want to do it. Okay. But you know, that's one aspect of it, right? Maybe you don't have a project that you're really interested in. Maybe instead you're thinking in terms of the job that you want to do in the future. And in that respect, I would say, you know, like having I guess good habits will help. You know, they don't have to be big habits. They don't have to be do a Leetcode problem an hour a day. You know? But maybe that would be good. I guess that's kind of what I'm doing at the moment. But you gotta look also down the line in your future and see like what do you eventually want to do or be or achieve, and what are some practical everyday steps that you can do to get there. That's how I think of it. And so for me, that's doing a Leetcode problem every day so I can eventually get a job. That's if I do this scheduler app that I'm building, eventually I'll be able to make it fundable, make it a viable alternative to having a day job. You know, so this is like a 10-year plan type shit. You know what I mean? So tonight says, how do you change your mission in life? For example, if you're obsessed with gaming like I was, how do you properly drop it and find something new to pursue for actual betterment of your life and fulfillment? Like, what do you do if you're too lazy to pursue those everyday steps to later achieve X job? Like you would fix, like how would you fix that? How exactly do you go about developing a free and open source software application? All right, I'll get to all those questions. So tonight. I'll address tonight first. So the thing is, like, me personally, you know, I've been obsessed with games before. We're talking, I played Valorant every day in the mornings, because we're talking like 6:30 in the morning. All right, that's one oddity. But at 6:30 in the morning, I would get up and I would play straight away for at least 2 hours before it turns 9 o'clock, and then I would eat breakfast, and then the rest of my day is normal. But I would still have, like, you know, a bit of gaming, right? So I know what you mean in the obsession part. Now, the thing is, like, from looking at that, you can kind of identify, for me at least, that it became a habit because I was waking up 6:30 every morning to play the game and finishing 2 hours later. Like, that is a clear example of me having a habit doing that. So I think even for you, like, the obsession with games could be just a habit that you have. And let's see. The thing is, how can you drop it? Alright, so how can you drop it? How can you find something new to pursue, the actual betterment of your life and fulfillment? That is a good question. Alright, so for me, how I did it was because I realized I wanted to build something else. Okay, so hear me out, right? So I had the scheduler app, but before the scheduler app, I actually was just playing Valorant. So I stopped playing Valorant and then I started doing the scheduler app. This is actually that timeline. So it kind of follows through. I'm doing the scheduler app now in replacement almost for Valorant. And so the reason being is because I found fulfillment more in building the scheduler app than I did for playing Valorant. And because, you know, at the end of the day, you kind of got to convince yourself that it's the right way. You kind of have to be a little bit, I guess, like, what's the word? You kind of have to be a little bit optimistic, I guess, that the app that you build is something of value, right? That is so much more value than just playing Valorant, right? That's at least how it got me off Valorant. And, you know, maybe I didn't want to, like, maybe during the first few months I wasn't really happy, or because, you know, like, I really wanted to play Valorant, but it wasn't like I really wanted to play Valorant. Like, okay, so look, the last day that I did stop playing Valorant was not even the day that I thought would be my last of playing Valorant. Right? It still might not be, right? I still could come back to Valorant and I could just play for fun with friends, but that's the thing. So now I've considered playing Valorant only now with friends. You know, whoever the friends are with me to play Valorant, I don't have that many to play Valorant with. I'm speaking so much now. There's so much to talk about. But so what made you addicted to Val? Like Radiant Push or just fun? That's the thing. So it was like, I wanted to get high up the ranks, you know? It was just a habit that I didn't know how to stop, you could say. But it was consistent. Like, it was never over 2 hours, right? That's how I could continually do it. Now, some people drop like Valorant for other games. They find other games and they do other games. But for me, I'm a level of addiction. I'm at a level of, I guess, obsession where there is only one game that I want to try and get good at. Or like, I don't want to play for the... I guess I do want to play for the fun of it, but I also want to be good at it. That's kind of my mindset. You know, like, some people just drop Valorant if they're not having fun. I can't. You know, that's the same thing for CSGO for a time. I played CSGO. I mean, it was from a young age, you know, it was probably, if anything, the sunk cost. That's probably what. Let's see, so Rayan, so you asked how exactly do you go about developing a free and open source web app, right? So that's the thing. I would say like literally just find a template online. So for me, this was the Fast API template. Use this and you know, you'll learn a lot. So just by practical applications of web apps, you see how it's done, and then you kind of work backwards to understand why they implement such and such ways. And if you don't understand, you know, how the front end is built or why it isn't built this way, then you go into the documentation of that specific framework that they're using. So this app is a good way to learn about all these different tools like Fast API, React, Chakra UI, stuff like that. Hi, can I get your Twitter ID, bro? Can I get your? Yeah. I don't know what my Twitter ID is. Oh, is it not even in the description? Yeah, Bell was never fun, but it was just a push, yeah. And also Tin, I don't know if you're still here, but yo, where are you interning next summer? It'll be in Sydney at Amazon. Okay, Flux. Look, my Twitter. Wait. Twitch. Oh, wait. Alright, that doesn't work. Hold on, give me a sec. Twitter. I feel like there's still so much to say about like personal motivation. One thing is, I am pretty known to yap and trail off my actual, I guess, question. Oh, okay, so I mean my @ is this. Okay, so David, it's literally, so Twitter, I'm sending you in, I'm sending it to Flux now. Yeah, I sent it in chat. It's that. Okay, how old are you? I'm 21. Okay, but back to like, just thinking about this. So tonight, I'm still thinking about your question. So what do you do if you're too lazy to pursue those everyday steps to later achieve? Like, how would you fix that? I guess in this case, it's still about maintaining that motivation, right? And sometimes it's hard because it's not something you can, you're easy to fool yourself. It's easy to fool yourself. So if you're too lazy to pursue those everyday steps, you might need to reconsider why those steps maybe aren't useful for you now. Maybe it's like the steps you're doing don't align with who you want to be in the future. Thinking about this stuff, like thinking about your personality and your identity is good for having a reason for why you don't or you do the habits. And so identity is talked about a lot in Atomic Habits if you read that book. So learning about habits, you can read that book. And it's foundational, really. Sure thing, Flux. Cool. The thing is, alright, tonight, yeah, it's just hard because studying something like mathematics is, as the math sorcerer, yeah, I've known him, says, lonely and very boring. But the end result of calculus, for example, is so beautiful and fun. Yeah, I agree. Like, I guess you have to also have solace in being lonely, you know, and seeing the boring things through. If anything, right, you can convince yourself that being bored is a good thing. In today's age, in today's day and age, nobody's bored, right? Or very few people are. So you can have solace in the fact that you can actively be bored by doing these math questions that you're learning, right? That's one way to think about it. Have faith in, I guess, the process, and that's really it. Yeah, at this point, being bored equals learning or doing something you should be. Yeah. Right? So, it's a good way to, I think that would be a good way to think about things, you know? Having a trust in the process. And that's, like, there's so many layers to just saying trust in the process. But it's literally just, you know, if you think about the different processes that could happen in the world, still being able to trust that process is gonna probably do you wonders, but also it's all very anecdotal and you don't know it unless you have people to tell you those anecdotes for it. Yeah, so Nahi, I recently started working on myself and I'm currently self-studying math and CS. Nice. You feel behind in life and I keep comparing myself to others. Any advice? Yeah, look man, okay, so the comparison to others is a big one, right? Like, I know how you feel with that. It's tough to think about it comparing to others, but it's tough when you think about things while comparing it to others, especially if you feel like you're falling behind, right? The thing is, you'd be surprised how fast you can catch up. You know, everything you've done in the past up until this point, if you feel like you're behind, that is part of the process. That is part of how you can become eventually good. The thing is, like, having the knowledge that you're behind on something means that you have motivation to actively change it, right? That's why you're self-studying math and CS now. And, you know, everyone's on a different journey. You know, people have said this before, but everyone's on a different journey, right? For me, look, I could have had my internship second year of my bachelor's, but in second year of my bachelor's, I decided to change my master's. I decided to change my major from pure math to computer science. All right, so to be honest, back then I was blissfully unaware. You know, maybe for the better, because I wasn't demotivated to actually find an internship or whatever, right? Because, oh, maybe I already passed the latest time that I could for getting an internship. You know, that didn't cross my mind back then. But after I graduated my bachelor's and doing my master's now, and me being in my penultimate year again, you know, this is where I'm taking up the opportunity, because I know I can do it this time around, especially with a master's degree. Think about it that way, like the time that you've spent in the world, comparatively to the people that you're going against, you're probably going to do it better than the majority, right? Okay, so hear me out, right? So I'm thinking, you're at your age currently. The people that you're trying to, I guess, learn, the people that are also learning the exact same content as you right now are probably younger. The people that are younger will probably be more aimless than you are, because right now you are motivated by the sheer fact that you're behind in life. Okay, so then how many people in life are actually aimlessly in their CS degrees at the moment? There's probably quite a few. And you're one of the exceptions that have the motivation to continue. Even, you know, you're maybe, I don't know how old you are beyond, say, when you were meant to first learn CS, I don't know, 2 years. But yeah, that's kind of like also another way. Like, you just got to find benefits, I guess, in the place that you currently are at. Yeah, anyway. Yeah, so not bringing him up again, but the math socialist states that you can catch up in subjects like mathematics in 2 weeks. Yeah, I saw that vid. I saw that vid too. I love that. I love that mindset. You know, he speaks facts. That's what I'd say. It's really good advice. And, you know, for me personally, like, even for the preparation for the Amazon interviews, I would have thought that I needed, you know, a solid 2 weeks to study all the, say, behavioral questions. But I don't know if, for the life of me, like, I knew I was going to have an Amazon interview, but then I didn't do any preparation until 3 days before the interview. Now, I had a full 2 weeks before the interview to do some practice, but I only did it 3 days before, and yet we still got it. We still got the bag. Because, I don't know, I believed in a process that even if I don't start straight away, that it's not gonna be bad for me if I just start now. I was like, if I procrastinated for so long, why not procrastinate more? Well, you know, you want to break out of that mindset, because You don't want to continuously procrastinate until you do nothing. Oh. Man. Nahi, I appreciate that, by the way. But yeah, look, man, like that's my thought process. I know I've rambled a little bit, and I'm pretty sure I make it somewhat overly complex when I say it. But yeah. Can you explain elliptical curve? No, I can't. I can't explain elliptic curves to you. I actually can't. Like, I know some basic ideas around it that I'm not even confident to say. Perhaps, you know, you got points on a graph and you jump between points on a graph on the elliptic curve to get to a point in the graph where the x value becomes your key. In an elliptic curve key generation, that is. But I can't tell you the details. I don't know the exact formulas or the exact elliptic curve. Anyway. Yikes, there's so much. So many changes. One by one. Your Leetcode contest rating? Probably 0. I don't know how to check that. Wait, what are we talking about when we're talking about elliptical curve, huh? Yeah, we are talking about an elliptic curve. Well, I don't know what Leetcode contest rating is. I know there's Leetcode contests, but not sure the rating. So what made you want to pursue math first? Did you want to get into quant? I guess you could with CS, but more so in the research dev side rather than the actual quant. Yeah, so the thing is, right, back then I didn't know any better. So you'd be surprised. So the thing is, for me at least, I didn't spend much time thinking about what I wanted to do at uni. I was just I had a belief that it's not what you want to do in life, but it's how much time you spend doing it that gives you fulfillment, right? That was my belief. Now, to an extent, I still believe it, right? But the problem is, with math, there was a certain level of, you know, boringness that got too much for me. Because I'm learning it, but, you know, even learning pure maths, I think I am built to build Legos. Like, I'm built to not be as theoretical, but more practical, right? That's what I figured out on my second year. So I realized, look, pure maths wasn't gonna work out because it was just too difficult for me, and the subjects I'd taken at the time, the most promising one that I did like, you know, I had like physics chemistry, computer science, all of these different subjects that I was just playing around with. So then I chose computer science because, yeah, it was just felt right. But even if it felt right, you know, like the thing was I was good at it. Like I even had signs when I was in high school, and we had this subject on digital technologies, which we wrote in Python. And, you know, the code that I wrote was also pretty foundational in the sense that it was a good solution. It's probably like 2 for loops and something else, right? It's like, but it was just good enough to the point where, you know, I got a commendation. I was commended by the teacher at my high school for building this code, right? So even back then I was kind of good at coding, so I guess that was something that just stuck when I got to uni, because here's the thing, right? First semester of uni, I was thinking, all right, my brother actually recommended me take this subject called Foundations of Computing. And, you know, at the time I was thinking, well, I kind of want to just do something in physics or chemistry or math. I probably don't want to do something in computer science, but I did this subject anyway. Man, that was like the best recommendation probably for my life trajectory. Because I can think back to a friend who's basically me in the same thinking, but he was never recommended to do Foundations of Computing, and he, you know, went down to be a chemistry major, but he didn't like it as much. So now he's changing to economics. But yeah, like if I wasn't recommended to do computer science, I probably would be more behind than I am now. Yeah, W brother. So, how many questions you should on Leetcode? Might want to rephrase that harsh. I don't exactly know what you mean there. But yeah, so I feel like every CS major kind of has the epiphany with the more theoretical concepts of the sciences. A famous example being Bezos dropping out of physics for that reason, yeah. I heard that too. The epiphany is, yeah, it's probably, you know, you're learning about yourself as you grow older. But I feel like you're at a point where you're actually more independent than I was back then. Yeah, so Nahi, problem with me self-studying is I always feel like I'm not ready, like there's no exam or grades. I've been procrastinating moving to Calc 1 for weeks, just redoing algebra and trig problems. Right. Interesting, right? So there is a bit of a, you know, you're like holding yourself back a little bit. The thing is, one thing for sure at uni is you can get pretty overwhelmed. Now, like if I'm just thinking about it from my perspective in your situation, like I actually would prefer to be where you are right now. And look, like there's a saying where it's like, the grass is greener on the other side, right? But it only looks that way, right? So maybe I'm looking at it with a grass greener on the other side perspective to yours, and you're looking at it the same way to mine. But the thing is, when you're in computer science at uni, they take no like you can't stop. Like, it's pretty pressured on you to do the subjects well. So I had to do 4 subjects every semester. Like, I guess that's normal, right? But it's still like a bit of pressure that you have to go through. And, you know, there's only so much you can learn. You can't really look into depth the problems carefully. And that's what made me dislike the university way of learning, right? So if I were to go back, I'd actually want to self-study math, right? Now there's no reason that I can't self-study math now. Like, I can do it maybe when I get a good job or something, and then I want to fill my head with something else other than building. Maybe I start going theoretical in life. And when that comes, like, you know for a fact I'm not going back to uni to learn it. I'm just going to grab a textbook and read it, right? And learn it that way. Because I found, like, I thought that was the way to learn, is to read the textbook and to make sure I understand all the things and then move on. That's the way I kind of want to do my learning for theoretical stuff. But in uni, you're pressured by 4 subjects a semester to learn as much as you can, do these problem sets, move on. All right, now you have an assignment. Now do the assignment. And you have no time to actually read the textbook in detail. Like, that's something I want to do. I want to read the textbook in detail so I understand fully. But that's not the way, uni is built. Anyway, so I think, like, Nahi, like, your way of doing things, although it's slow, it might be beneficial for you in the future because you have a more foundational understanding of the concepts, you know? So going slow might be good for you. Just make sure you don't go too slow to the point where you're stagnating. All right, that's one other thing. All right. So Harsh, how many questions you should do in Leetcode? So for me, I did 70 questions to get my Amazon internship. Now, you know, it wasn't just Amazon that I was going for. You know, there was other big tech companies I also was trying to get into that I passed their OAs in, because I did, you know, I did less questions as well for those, but it just turned out to accumulate all the way up to 70 Leetcode questions. But I'm not stopping because I want to try get into big tech. I want to go into like Google maybe at some point. So so once you graduate your uni, no matter which uni it is, can't you go back without enrolling and just take any course you want? Obviously, still has to pay for it. For X graduating from MIT in 1970 and taking AI today. I didn't know that was actually a thing. I actually didn't know that was a thing. If that's actually a thing, then like, you can go back to uni whenever if you really wanted to. So that's for sure my thoughts. That was definitely a good long discussion where I just yapped a lot. If it is, that's kind of sick. It could be. I mean, it doesn't sound implausible. Because after all, for me, I got admission to my master's pretty easily, given that I already studied my bachelor's at the same university. So if you think about it also, like these unis kind of want your money. They want you to continue studying for their own growth, so to speak. Growth. I gotta make sure these are all sanitized. Oh, for sure, for sure. Oh man. Okay. We will see. So this should do this. Whoops. Should do that. Admin is just 8,000. Oh no, 8080, right. Traffic UI is 8090, right? Okay, sure. But yeah, I guess it's fine. You just looked up Harvard and MIT have same with most Oz Uni. However, for a few Oz Unis, they only offer a few courses like business/languages. Unsure about the maths and CS side of things. But either way, you adapt on the job, assuming you aren't fired by big tech moment. Yeah. Yeah, so I mean, anyway, like once you get a job also, like always have the mindset that you'll be learning on the job. You'll be learning things throughout your whole life. Like that's another piece of mindset that I know a lot of my friends where I live can't live with, I guess. Tiangolo. I guess it's fine. Just gotta change it. How many? This is how many selected? 14 selections, yikes. That's not 14, that's 3, 6, 7. That's 7. Where are the others? God damn it. Oh. Yeah, of course. I'll change these. Delete. Insert. David Shaw. Ooh. Actually, that's not good. Redo. Let's see. Just keep on scrolling. Okay, well, undo. We're undoing that. Yikes. Okay, so that's gotta be changed. Damn, there's so much to change. Okay. By the way, yeah, so what were your fave courses back in Unimelb undergrad? Currently third year, Sem 1, ran out of subjects to choose. Hey, alright. Hey, not bad. Hey, we have a Unimelb person here. Let's see. So wait, you ran out, so currently third year, Sem 1, ran out of subjects to choose. Is that really? Whatever. What were your favorite courses? So I would say, you know, Foundations of Computing was pretty nice, you know, even in first year. But I mean, if you're talking about breadth subjects, I did like Entrepreneurship, Principles and Tools or something. I think that's what it was called. I don't know if that subject is still alive now. But well, I also did Music Psychology. I guess the IT project was also pretty nice. I liked doing the IT project. But the IT project wasn't breadth. Okay, well, yeah, completing all core subjects. Oh, I see. I gotcha. Well, so the other CS electives that I did do though, is kind of interesting choices. So music psychology, it's pretty chill. Like I did it over the summer because I switched my majors in my second year, and that meant I had to make up for one subject in the summer, and that subject turned out to be music psychology. So I did music psychology, and that was pretty normal. It was like pretty chill, you know. It wasn't bad at all. You just write an essay at the very end. But I want to bring up like my transcript, so give me a second. Okay, the subjects I did in third year, right? Music psychology, elements of data processing, I think that's maybe elective. Then another elective was declarative programming, right? And artificial intelligence. So I kind of chose tough. Wait, I don't know if artificial intelligence is or not a elective. I think it is. But yeah, I did that. So I kind of picked hard subjects on purpose because I want to kind of learn hard things. Yeah. Wham reveal. No, I'm not showing that. But it was okay. It was above 75. That's what I can say. You're doing DP this sem and EODP last sem. Yeah, fair enough. Nahi also. So definitely stagnant right now. That's one reason I want to go back to university, to prove myself through grades. I didn't put in the effort during high school. Now I feel like I need the validation. I see. Yeah. If you think then, if you think it's going to be helpful, then yeah, for sure go back to uni. You know? I mean, it's probably... There's no reason not to, I would say. Even with the stress that it gives you, but regardless. There's no reason not to. But don't feel like you'll be behind. It'll just mean when you're in with the same group of people that are maybe 3 years, 4 years younger than you, just know that you're more mature than they are. And you're going to take it seriously, you know? That's always a good mindset to have. You're going to take it more seriously than most of the people there. Most likely, I would think. Just by the nature of our brains. Okay, so there's more of this that I will do later now, I think. Enough time that we've spent on that. We can tick off scheduler development. Now, I finished the rest of the exam paper questions, so that's really close to done. The thing is, I can finish these two tonight, possibly. But they're going to be hard to finish. But yeah. How are you so wise? I mean, I've read a lot of books, I guess. I wouldn't say I'm the wisest. I wouldn't say I'm the wisest though. But I do want to think about life in the long term, I guess. If it's anything that convinced me to think of things well, it's the fact that I want to think of things in the long term. So it's part of like an ingrained, I guess, it's maybe not ingrained exactly, but when I was young I also was quite thoughtful in the long term. But it doesn't mean you can't, okay? It doesn't mean you can't be, but the mindset of having things in the long term really shifts the way you think about what you do on day to day. Okay. That's what I can say. Like for me, maybe like, you know, I read a lot of what you call self-help books. You could say that. So why would I read them? You know, one of the books was about, it was called Barefoot Investor, where you learn about how to manage your money well. So that, you know, the idea is in future, if you have good investments today, you can reap the benefits of time later in life. And so that's why I also invest in stuff as well. But the normal stuff, or like the stuff that doesn't take up my days and doing day trading or whatever, none of that. You're in my garage, you bought this new lamp. Yeah. Yeah, exactly. No, but like, honestly, like the books that I read were pretty good. Like, say during 2020, during the pandemic, I had a lot of time to reflect on stuff, and so I read books a lot to help me. If I go to my books app. No, you're fine. You're fine tonight. It's actually funny. What? So this is where I did the books. So these are the finished books, I guess. So roughly 25 books, I guess, all in the genre of self-help, you could say. All right. All good, Nahi. Good night, man. I'm domestic. But yeah, the first book I ever read, Atomic Habits, 4-Hour Work Week. This was actually not that helpful for me at the time, I think, because I was literally just out of high school. I want to read it back over again. If anything, the best book to read is Atomic Habits. And everything else is just a supplement to that. Deep Work is good, but I also read this too early, I reckon. I've already reread it. How to Take Smart Notes is somewhat good. It talks about the Zettelkasten method. But then I also didn't apply most of what this said and just did my own Zettelkasten. Don't worry about this one. I read this one also, How to Become a Stray Student by Cal Newport. That was also pretty good. And the rest is pretty straightforward. Barefoot Investor was also good for just finances. Psychology of Money was just one to fortify my understanding of what I already knew. But yeah, that's pretty much it. So how much is Atomic Habits? It's like, I think I bought a hard copy for like $22. But like recently, I bought it recently. Kasara, so do you have any tips for exam prep? My first exam is 2+ weeks away and you can't be stuffed. All right, well, the thing is, with exam prep, you want to do as much questions as you can, as many problems as you can, and make sure you understand the problems fully, right? So don't just look at the solutions and be like, okay, that's just that, without fully understanding why it is the answer. Okay, this is like even how I do things in Leetcode. Understand things. All right, even if it takes you a bit of time, you know, if you're stuck in fully understanding a question, don't fully spend all that time just stuck on that question. Like, move on, right? You want to move on and do more questions, so you got to keep a balance. That's the thing. Don't spend too much time thinking about a question, because you can come back to it later, and you can also ask your peers about it during the 2 weeks. Right, so that's what I'm doing as well for some of the questions. Like this question that I had, I posted this question, I asked the discussion forum and we got a response here. And I still have questions here, so I'm still asking, but I'm not gonna like stay on it so deeply until I figure it out, because that's not gonna be productive for you. Do you have a calc book recommendation? Yeah. Okay, here's the thing, calc. I used a book called Calculus Early Transcendentals to learn about limits, to learn about just calculus in general. But this was ages ago now. I haven't used this in ages. It was similar to this. I'm pretty sure this was pretty much the textbook. Yeah, anyway. So Qua, I always wanted to read more, but how do you absorb that information? I read Atomic Habits last year and don't even remember it. Yeah, so look, that's the other thing. Like, yeah, you can read a book and never catch the information fully. And that's the problem is we need to like reflect on what we read. And just reading the words don't necessarily mean that it doesn't just flow out the back of your head and disappear into nirvana. You want to be able to encode the words in some way. Maybe, you know, the crucial parts you want to encode. The rest of the book you don't need to, right? But the crucial parts, in the sense that, look, the things that I remember out of Atomic Habits, what was it again? Action and reward. It was something and something action and reward. It wasn't situation. I'm thinking of a star framework now. I'm thinking of a star framework, but okay, let me search this up. God damn it, no. I can remember. Action and reward. Before that, it is Q craving, action and reward, right? Q craving. Is it Q craving, action and reward? Yeah, it is Q craving, action and reward. That's it. Yeah, so Q craving, action and reward. Remember that. All right. Unlike me having not like fully remembered it. Oh, you think that's the Unimel Calc 2 book? Yeah, I think I've seen that book around actually, to be honest. I have seen that book around. But okay. Q craving, action and reward. If you remember those words and then, you know, think about what each of them mean. That's all you need, man. Q. What causes you to start a habit? Craving. Why is that habit? What craving does that habit give you? Right. Action. You perform the action from having that craving to do the action. Reward. What do you get out of it after performing the action? So for me, if it was Valorant, the Q would be the I don't know, me sitting at my desk and I have my Windows open. I have Windows OS open. I have Valorant in the top left corner of my screen. Let's see, I can actually just recreate that scenario. Look, I'm on my Windows desktop right now. Oh shoot, my Valorant is right in the corner here. I gotta open it. Like, the reason is that's the Q. Then you got some craving, which is, oh shit, I want to play Valorant right now because, you know, I want to just relax for 40 minutes and play a game, right? And then you do that. You do the action of playing 40 minutes and playing the game. And then the reward, well, the reward is you don't have to think about other stuff. All right, now the most crucial part is the Q. What's the Q? The Q is having the Windows computer open. But it turns out that the Windows computer that you open is also your workspace. So how do you segment that? How do you make it so that your Windows computer can be unconditioned to be your, I guess, reconditioned to be your productivity device or whatever. I hate saying productivity device or anything productivity. And not more like your gaming device, all right? How do you do that? That's the question you want to ask yourself. Atomic Habits sounds like the title is trying to portray min-maxing, right? And optimizing the tiniest things in life to snowball into a more fulfilling reward. Yeah, so look, honestly, yeah, that is, like, it's literally doing the little things in life which could end up snowballing, right? Now, one of the other, like, comparisons that Atomic Habits makes, which I remember, is that improving 1% a day, right, means that by the end of the year, you improved by so much more because of the compounding effect. But the thing is, just one thing there is, you know, that's good and all. But also consider how much 1% becomes on your first day compared to the 354th day or whatever. right? Then you think like the 1% maybe on your first day meant just doing one push-up. But your 1% on your 356th day or whatever, one push-up isn't 1% anymore. It's probably like 100 push-ups to do that 1%. So the problem of 1% compounding, yeah, it looks good. That's just one thing to say. It looks good. It sounds good. Which it is. It pretty is good of a mindset to have. But just saying 1% gets harder and harder every day. So don't have to keep yourself on 1%. But the thing is, nobody knows how to gauge a 1% either. So like I guess the whole concept is like doing a little bit every day is good for you. It'll compound you in life. That's the idea. That's the concept. I don't need to go into detail further than that. Like, yeah, 1%, it just means like do the I guess little things that make it good in life. But yeah. Anyway. Now, I can probably close these windows and close Windows. And I can go back to Mac here. Now, the thing is, it's 6:41. Yeah. I gotta at least read some of these questions. I'm not yapping. Oh, thanks, man. Yeah, I really hope so, man. I really hope I'm not just saying stuff. Anyway. Alright, so all good, all good, man. Kasahara. All good, Kasahara. Sleep well, I guess. So Qua, every time I try to improve in my case, just studying, I feel so alone, like I'm missing out. Stuff is happening and I'm sitting at my table doing math. It always leads to me scrolling social media. Yeah. That's, okay, like that's relatable. I know what you mean. Another issue with that, you know, is the problem of comparison, right? It's hard. It's hard to, because comparison is deep ingrained within our identity, right? The people we see on Instagram who are doing things that are similar to us that we could possibly be doing ourselves, that we aren't doing because we're stuck here doing math or a problem set. I guess the thing is, really, it's like, for me, it's hard to do this, but you gotta be, I can't say you gotta be, but being oblivious is good. Alright, sometimes it's just like, don't even look at social media. Don't even look at what other people are doing. Save yourself the comparisons and turmoil that comes with it. You know, it's, for me personally, like, I can imagine exactly what you're feeling with how I've felt. Like, it's like a problem that I even have, like, right now. But maybe not with math, right? Not while I'm doing math. Or maybe not when I'm studying, but I do feel of missing out, right? The thing is, like, with missing out, it's just I gotta put my head out of the scene. right? So maybe that's what you got to do too. And just keep your head out of the scene until after you finish your problem sets. Maybe that's not the best advice, because then you're just oblivious to life, I guess. But yeah, it's definitely a hard thing, man. Oh, okay. Yeah, nice. All good, all good. Well, look, I hope the explanations are helpful. That's partially why I'm here, because I want to speak about this stuff too, you know, through action and through questions that, you know, I get asked. Yes, except p equals 2. Yeah, okay. Any number mod p being 1 and p minus 1 is co-prime with p. Yeah. I guess because it's also modded, right? 2p minus 1. When you mod that, that'll be, yeah, obviously. Man, I should have just, thank you, Zenji Lai. Should have just realized myself. Dude, math notes in an actual notebook is fun, but so slow. Look, I did that for so long in high school. I'll tell you, that is literally how I managed through high school. The problem is that wasn't the best way, right? That's like, you know, it's so slow, right? Like you say. And it is true, it is slow. And the only benefit that I saw from it was the summaries. In this, well, obviously, but in the sense that when you have these summaries, you have the structure right in these 1, 2, 3, 4, 5 pages or whatever that you write, because you're condensing it all. Now that's good, but also it takes forever, and I don't think I would ever want to do that again. I don't want to make my notes neat again. I don't want to do any of that stuff. Like, there's just not enough time in the world to do that anymore. And it's way too... I would get probably some sort of calloused thumb after that, or whatever, like a calloused finger where I rest my pen on. And then when I do have that, that would... Man, I did have that. Like, I had a callus on my finger where I rested my pen on. And that was all in high school. But now there's none of that. Like, literally it's just this this Apple Pencil plus an iPad. This is all I need. The iPad's like, I don't even write notes beyond the ones that I'm writing in, say, Obsidian. Like, look at these. Like, these are all just the ways I'd write things in Obsidian now. Both textual, like, if I have to write more text, then I would just write it in text. Math notes, I would write it in these Excaliburs. Yeah, I just crave the ability to have an infinite amount of pages on a tablet. My ass is... right now I was just using a ruler to make the notes super nice. Yeah, man. How are you able to stream for so long with school? I mean, that's the thing. I'm just streaming while studying, so that's just how it works for me, I guess. Except, you know, I've been talking for the last hour, I guess, which isn't actually that helpful, but I guess, you know, it's keeping me off, it's like giving me a break, you know, so I don't discount it as bad as well. Definitely not bad. But yeah, like, I used to rule my pages on my math notes, right? And I would rule them very neatly into, like, where you have the full page open and 4 columns in total by the 2 ruled middle lines. And then I would think like those summaries that I would write would be so detailed, right? And I would love to do that again, but we just don't have time now, right? Actually, I don't love to do that. I don't want to do that ever again, to be honest, because of the calloused fingers, because of just so much hassle for learning something so simple in a sense. It's not worth it. That's all. And I've been making my notes less clean. I'm making them more messy, and I reckon that's done more good than bad, because I get to focus on the concepts more than on the typography, right? Anyway. Cool. How much are iPads and what are the apps you could use for drawing notes? That is a whole nother can of worms, but the iPad that I'm using at least is the iPad Pro 12.9 inch, I think 2021 maybe? No, it's 4th gen iPad Pro 12.9 inch. So it's the biggest like physical iPad. In retrospect, I would buy one less, so one size less. I would go 11 inch, just for the physical holdability of the iPad. And in terms of the notes, right? The notes, I used pretty much all of them. I used Notability, that was paid. I used GoodNotes, that was paid. The problem with those two are that they're now becoming subscription based, and I hate that. So I switched off I've switched off Notability and GoodNotes for Obsidian, where I'm using Excalibur. Okay, now Excalibur is like 10 times worse in terms of the UI than Notability, but it's still usable, and I've decided like that's all I care about. As long as it's usable, it's good, and it's free, right? So I think the main factor for me at least is that it's free. Even the bugs that maybe like the screen bugs when I'm pushing my palm on the iPad, those things are like actually not that bad to me in comparison to using Notability as a subscription. So I hate that, right? That's part of my feeling on things. Yeah, so that's the iPad experience for me at least. Using the actual Notes app itself. So if we're talking like the Notes app, actually just using the Notes app itself and just writing on the Notes app, like, right, just like writing on the actual Notes app. This is also a pretty good space to do that, just random notes if you want to just add them, like you're just doing a practice problem real quick. All right, let me just write out the answer real quick. You can do that really easily with this iPad, just in the Notes app. So with Obsidian, how do you start? I like the idea, but it looks complicated, and I always end up spending so much time making the Obsidian notes. Yeah, so that's the other thing. You kind of gotta reduce your expectations a bit, I guess. You know, when you start out with Obsidian, use it blank, like use it as a blank slate. You know, you gotta kind of like think of it as, you don't need it perfect, right? That's the biggest problem that I faced personally as well. Like, oh, I need my Obsidian perfect. I need the exact extensions. I want the exact extensions. Oh, how do I find one that's free? Or whatever. Or like, how do I connect my notes in a way that's the best or the most optimal. Problem is you don't want to think that way. You just want to connect nodes where you can. And if you can't, it doesn't matter. Right, for me, look, I put a whole subject's worth of learning in one note. In one note. Not one note, right, but one note. Cryptography and security. Right. One note containing all of the content of this subject. Look, that's not perfect, right? It's not really atomicizing these things, but I don't want to atomize these things. These things don't need to be atomicized. I think about it like logically, it doesn't, because this is a structured course. By atomicizing it, you make it messy, and there's no need to make it messy. Right? It's hard enough as is to study the content. And like, look at me, like I'm using dot points here, but then using checkboxes here. Like this is messy. The point of it, it's meant to be messy. Look, I put exam revision here when I haven't even finished my last week of lectures. You know, I should be putting this underneath my revision lecture stuff, but I just don't care. You know, I know where to find things if I need it. It's just all gonna be here on one note. So the thing is, like, don't spend too much time thinking about making it look good. It's the killer of time. Are you in uni or something? Yeah, I'm in uni. Melbourne Uni. That's where I am. All good, Kwa. So, like, see, like, with this updated note, like, I would say something about this now, just in my exam prac. So, I would say, like, look, I gotta rewrite this part, because this is all, like, done, like, I gotta rewrite this whole part. So this is what I'm gonna do, right? I got my iPad here. I have everything here on the left to tell me what's the correct way. I will say, okay, like I did it wrong here. I use orange because that's the color of me completing, looking at the solutions, so to speak. And then that error would show up eventually, actually. I don't know when. Oh, actually, maybe I need to just close things out for a sec. That's yeah, see, like I have to close things out for it to start syncing properly. That's one other thing. That's just you know, something you deal with when you just pick Obsidian on iPad. So then I would say, okay, if p is equal to 2, then 2p minus 2 of so 2p minus 2 is going to be even, right? So 5p minus 5 plus 1 plus 1, this whole section is even. Sure, that whole part is even. So when you have plus 1 to that of p minus 1, it's just still going to equal to mod p. So mod p is going to equal to, so if that whole thing is even and that p is equal to 2, then it means this whole thing inside becomes 0 plus 1. P minus 1, and now this is just equal to 1, and so the answer is 1 mod p for if p is equal to 2. Now if p is equal to is greater than 2, Alright, so P is a prime. If P is greater than 2, then you can reduce the equation, you can change the equation a little bit. The 5P, so look, 5P minus 5 plus 1 is what we have. So minus 5 plus 1. This part is equal to 2P minus 2 5 times P minus 1 plus, or like actually instead of plus it just becomes 2P minus 2. So then this whole expression, because of the Fermat's rule, not Fermat's, Euler's theorem, this whole section becomes 1. So all you're left with is, not Siri, all you're left with is 2P minus 2. So if you're left with 2P minus 2, and also look at how messy I've made it, right? So far, like we got an extra equal sign. We got a almost crossed out 2 when it shows up. But you got 2P minus 2 as that value. And then this part, I put another arrow to say 2P minus 2 plus 1 P minus 1 mod P. Now then the thing is, it's 2P minus 1 P minus 1 mod P. And I say finally that because of the fact that 2P minus 1 and P are coprime, then this is also equal to 1 by Euler's theorem. Alright, so this is the final solution. This is the correct solution. Maybe I circle it and say correct solution. The point is, like, make it messy. Make the thing you're writing messy, because it doesn't matter. Yeah, that's my trap with VS Code, which is why I swapped for IntelliJ for Java/Python. Yeah, interesting. I never thought about it that way, actually. Can't be asked with UI and add-ons. That's it. The thing is, like, yeah, I was trapped in like customization hell at one point. So I'm happy to not be enslaved by that anymore. So message authentication is achieved using message authentication codes, duh. And yet I picked RSA. Key distribution often involves the use of a master key, which are infrequently used and are long-lasting. Oh, yeah, that makes sense. Infrequently used and long-lasting is the key word here. Infrequently used and are long-lasting. Exactly, the master key. You just want a super clean and minimalistic UI for optimal efficiency. Yeah, that's also what I want. Yeah. I like minimalism to the point where I try to keep my table pretty clean as well. But like I got a dual monitor arm the other day. We got that like set up in a way that it's got 2 monitors on the sides here that doesn't take up the desk space as much. Minimal, maybe. Maybe considered minimal, maybe not. Maybe consumerist, if anything. Give me a sec, I'm gonna get some water and be right back. Okay, so user wants to design a CPA secure public key. What is a CPA secure public key encryption scheme to be using for emailing large files? One of the following which would be the best approach? To encrypt a file M, hash the file to get a short value H, and then encrypt H using LGAML encryption. Yeah, LGAML encryption. To encrypt a file M, use LGAML encryption. Yeah. I gotta look at this after. I gotta find a note to specifically this answer also. But okay, P plus Q divided by N. How would that be? P plus Q divided by N. Gotta need ChatGPT to answer this one. Let's see. Hey, yo. Let me see if this is right, because the answer actually says it's A, not B. So ChatGPT might be wrong. Oh wait, do I want to sneeze? I got it out. Okay, the question asks for the likelihood that a random generated message has a common factor with n, where n is equal to p times q in the RSA, with p and q being large prime numbers. The likelihood that two random chosen numbers are co-prime, i.e. they have no common factor other than 1, is approximately what? That two randomly chosen numbers are co-prime, where n is the product of two primes. Since common factor of n would require the number to share a factor with p or q, the probability that a random chosen number has a common factor with n is very low. I need you to retry, man. I don't even understand that. Hello, Matthew. Hello, Matthew. You're still giving me 1 divided by n. But why? I'm gonna try without the markers. Alright, just gotta see if it's biased. Now I'll open a new session. E, what the fuck? It chose E? So smart, ChatGPT. I'm joking. I'm joking. No, I'm not gonna look at LinkedIn. I'm not gonna say I'm not gonna look at LinkedIn. Okay, I will look at some of these questions here. Can we say that hard problems can help in build public key schemes because they can build one-way functions, while each instance of the function can be used to calculate some interesting values? Yes. Okay. Okay, I need to do more of these questions. How do you determine the values of the multiplicative order column again? Ooh, yeah, how would you go that? Okay, I'm gonna redo this one. Markers on red. Starling's meaning of auth. In Starling's it says that 4 methods of auth. Which category does 2-factor auth come in? It's something that someone possesses, I think. In my opinion, 2FA, 2 different authentication processes. First, let's use LMS utilize 2FA, the password and the octocode to authenticate you. It assumes that only you are in the password and the correct code. The LMS does not care. You have access to code and just simply assumes you have the correct code. So I'll treat it as the 2 possessive informations to access this. Yeah, so it's possessive, yeah. Second, the fingerprint is not related to the LMS, but it's also how the octa auth you. So there are 2 individual authentication processes. In this case, you decide for the second authentication, it is what a person is. I agree. I agree. Will not examine the TLS layout? Epic! Perfect, I didn't want to relearn TLS again. I'm about to eat dinner actually. Okay, here's the thing guys, I think I might call it a night. Just because I wanted to spend some time winding down, because last few days I've been sleeping later. So I'm gonna try just calling it a night for tonight. I'll be back here tomorrow in time, but for now I'll be done with my stream. So thank you everyone for sticking along, you know, I appreciate you guys, and I'm gonna be doing some more even after this stream, after I've had my dinner. But yeah, so I'll catch you guys in a bit, and thank you tonight for chatting tonight, because the thing is, it's good to have these chats, and you know, they're good content that I might even like make into highlights or something. So appreciate it, appreciate the thoughtful questions. All right, catch you guys, peace.